Hi. Which kind of mic do you prefer?
Probably holding.
This?
Yes, that would be great.
Poi, semmai quando fanno le domande, se lo scambiano. Quindi, e poi quando fa le domande,
L'importante se c'è domande dalla sala fagli usare il microfono perché sennò da casa non le senti.
Sì.
ora la presenti? La presenti? Era più semplice una cosa.
Can I? Welcome everybody to Room Spaghetti. We are here with Anastasia Timoshuk to talk about continuous documentation techniques. So welcome, Anastasia. Thank you.
Thank you. Well, now I have the mic, so I can speak. Hello, everyone. Today we are here talking about documentation, so a few words about myself. I came here from Berlin, from not sunny Berlin, into a very sunny country. I'm so happy to be here. I'm working as an engineering management manager at Strava in Berlin. Probably you all know Strava application. And I'm also a PyBerlin organizer. It's a very nice welcoming meetup. So if you are around in Berlin, please come. And I have around 11, maybe a bit more years in software development. I really love Python. Should I move? It wasn't Python. I really love Python. It was my first welcoming sort of language. I came from C++, and then when I started with Python, I fell in love with the language and the community. And especially in Berlin, it was so nice to feel supported with the community. And that's why I'm here, also sharing my experience over the years. Although I'm not writing much code, but I am suggesting to my teams about best practices, and one of them is documentation. So this is our talk today. And I would like to ask, please raise a hand if you do document your code. Oh, wow. So why are you here? OK, probably you know everything. Let's see if you know the stuff that I'm going to share. So me 10 years ago was like this. I didn't think that documentation is very important. Especially when I started with Python, I was using a lot of documentation to learn, and I didn't document my code. So what happened? It was a new project we started. It was an automated framework that we wrote for LG Smart TV as a team of 10 people. And you know what? After a year, we didn't know how it works, which was fun. And that's when we learned the hard way that documentation is very important. Not just the comments, but more on the documentation level that I will share later on. So why is documentation important? Probably that's why. One of the ideas is that people forget things, and that's why you need documentation to recall what's actually happening. Then the next one, people leave the code alone for some time. Even if you are a core contributor, you might leave for like, I don't know, a few months, and then something happens, and then you don't remember anything anymore. For example, I don't remember anything for like a previous week from my work when I took 2 days off, and then I forgot everything because the life is so intense. Well, I also have a baby, so you probably would not remember your code that you wrote like a year ago. And new people contribute to your code, especially if it's open source. It's very important to see how to contribute to the code, not only how it works, but also, well, a lot of information that is needed. And how to start with documentation. Well, I saw that all of you already have some documentation, so maybe this is not so important, but might be that you might start with some of the items that I'm going to share. All right. But we are here about to talk about documentation, how to actually have it up to date. First is that you need to choose the main source and the tool for documentation. The problem that I encountered in my experience was that the teams had too many tools. So they had documentation here and there, sometimes on Confluence, sometimes in Google Docs. I mean, those are good tools, don't get me wrong, but if you have multiple tools, not even one place, then you will not be able to find. And right now, a good thing is that we have AI, so we can already connect one tool or like multiple tools that you are aware of. This is a very important fact that you need to know where documentation is. You can connect them all into one place, and then you can have a very smart search. So this is something that we're doing right now in some of the teams. But actually, first you need to choose the tools that you want to use and how. And then make sure it's up to date, right? So you need to keep it up to date to be able to recall what you did. You need to also add this as a part of maybe every PR or every second PR. Would be nice to have it in the CI as well. And you need to build a team culture around documentation. It's not only about writing documentation, updating that, but also about reading documentation. Because if you have documentation still, there might be some person, you know, that person works and stays with the company for their whole sort of life. 5-10 years feels like a lifetime. And then people tend to just come to that person and ask, how do I do this? How do I do that? So what would I suggest you, if you are that person, is to just send them links. And at some point, they will get annoyed, which is so true. It works like that. But actually, if you are the person who is asking those questions from that specific person, if you do have documentation in your company, maybe it's time to bring it up to date. If there is no documentation, maybe it's time to start with documentation, because that person is a very probably senior person within the team, and you're using their time to answer the questions, which is not ideal. Obviously, they can contribute so much more. So let's start with basics. I hope that I convinced you that documentation is important, but probably you already knew about this. This is the code that I took, for example. Very simple one. It has 2 functions, and it's not very clear what does it do. That's why we are going to look into them. So the first function is just not doing anything. It's just returning the message. And also not clear what does it do next. What should I do with the function? The next one, also not documented. And it has weird params. It does something, and maybe it doesn't do anything with them. You don't know. So how to add documentation to this code? There is some secret that I'm going to share with you. Maybe you already learned that. So there is a link. You can go and check more information. This is from Daniele Proceda. He also gave the talk in, I think, was 2017. And it's awesome. It was just fantastic. I was so inspired by this talk. And I learned that not so many people probably watched that talk. Also, I didn't watch that talk. I found on the internet that link also with different types of documentation. So one of the approaches that I'm going to share today is to add the how-to guides into your documentation. So we're going to talk about different types of documentation today, not only about the standard approach that you probably have seen, just add something, how it works, and then you're done. No. There are different approaches that you probably need to accommodate all of them for your code. So one of them is the how-to guides. It's the goal-oriented approach. And those are the guides to take the reader of the guide through some steps. So it's very important to focus on, for example, it's like a recipe. The direction that you go, you would see there. And for example, in the code that I shared, would be nice to have a README with some installation process. So there is always a goal to this piece of documentation. Like you start somewhere, and then there is the certain end where you finish. Second approach is the learning-oriented approach. Those are the tutorials. So those are basically the lessons to learn stuff. So it doesn't have very specific goal, but the goal is to learn. So it doesn't mean that it would be like the full project, but it's for the reader to learn, for example, how to use that tool or how to contribute into your repo. And for our example, I wrote a tutorial on the basic setup of Sphinx, well, documentation. Next one is the explanation. This is understanding-oriented approach. So this approach will clarify a bit more information on the subject. It would also expand the information, so everything that is not included into the previous steps, something that you might need to add extra for people to know about your application or the code that you're writing. for example, it could be some advanced techniques. Why is this repo needed? Why is this tool useful? Can be something like that. So for example, I wrote the explanation of why documentation is needed. And the last but not least is the reference. So this is the information-oriented approach. It would have a code reference, so it would have aggregated all the doc strings that you might be already writing. From the code that you have, it would be nice to also describe the classes, the functions, the APIs that you have to already see it up to date. So if you, for example, have it, but you don't store it as documentation, you can have it continuously updated. For example, if you add one of the checks to your CI, whenever somebody adds a piece of code, it should be documented. Very nice. And then it would fail if there is no documentation. Or if it's not possible, for example, it could be one of the checks for the code review within the team. And then the teammates would keep each other accountable about how to update the code, what should be updated, what type of documentation you need, and so on. So this is the code reference that I built. So I just added the doc strings into a very simple application, used Sphinx, and served it to read the docs, which was for free for open source. And also there is a paid-for solution for the companies. And here's the secret. In other words, we call documentation, what we call documentation is fundamentally not one thing, but four. Understanding the implication of this and how those four different things work can help improve most of documentation. This is the citate from the source that I link in there. And it's very nice to understand that documentation has different shapes and forms. It has different types. And the more you add, the more it becomes a full documentation. So it would be the code reference, also some README, some information that you can share with the reader. It could be also tutorials, some basic setup of the application. And it could be more explanation and the why of this project. And then, this is how I feel. Not always like that, because it's very hard to keep that up to date. So how to actually start? What I did for this project, I started very simple. So I went through all the layers and I added one by one, which was very useful and nice. Since it's an empty project, it doesn't have much. It was very easy to add. If the project is very big, probably you need to define the milestones, how to add documentation. And I would suggest you to go to version control documentation. For example, read the docs. It can also build documentation from the branches. It can build from like the different versions, different releases. And of course, if you can add doc strings to your code, not the comments. The comments is a bit different. So comments are for developers. It's very nice to have comments, but documentation is not only for developers, but for people to use the package. For example, if you are trying to use one of the packages and it doesn't work, where do you go? You go to documentation. You go to check README. You go to check some information, how to fix the projects, or then you go and contribute and fix the project, right? So those are different things. And if you have just doc strings, then as a developer, you would have to go through the whole code to understand how it works. That would be taking a lot of time. And you can use any of the tools to prepare documentation. I used Sphinx in my example. It was very nice, convenient for, well, many years. It was like 10 years ago when I started documentation. So you can also try some of the hosted solutions, like Read the Docs, GitHub Pages, well, anything that you think is more reasonable for you. There are lots of solutions. And of course, add more documentation on the top. So this is the code that I shared. There are some examples. There's also the CI setup. I also added some security checks. Also, there is a very nice tool which is called Interrogate, which goes through your code, and then it will tell you what is the coverage. You can put the maximum, well, minimum coverage to pass the CI. Also works. So this is how read the docs looks. There is a very nice setup, super easy. Not easy to install the things in there. So basically, if everything is installed in there, you can run it. For example, Jupyter notebooks, they just run, I think. I tried it last night. It did run. It was building very nicely, so you didn't need to install anything specific. You can install packages in there, Python packages. But if you need to install something specific, that would not work. That's what I had for this talk. So this is the example with some simple documentation. This is all I shared before. There is code reference. There are different pages. You can go through them as well. And more stuff that I wanted to share. So first idea was to add some interactive Python in there. Would be nice, right? You have some Python, you write the code, you execute it, and then you see the results in documentation. Maybe not needed, but fun. So what I tried, I saw a talk from Jeff Glass, I think it was 2024, and it was very nice. So it was so nice, so great, it works out of the box, and I tried it. Well, to be honest, I tried it this week, and it didn't work, and I was panicking. Okay, what do I do? It doesn't work at all. Then I saw that that project, so it's called Sphinx PyScript. It's supposed to add PyScript into your documentation. So you just install it, and then it works out of the box. It doesn't. It doesn't really work at all. So what I did, yeah. So this is the talk, PyScript documentation. You can check the talk as well. You can also search for it. It gives you an example of the PyScript. It works so nice. And this is the whole code of it. It's not so much. You just install the application, PyScript, and then it's supposed to work. This is the demo. Yeah, this is the application. So this is the package, Sphinx PyScript. But you can see it's 2 years, 3 years old. Quite old, right? And there is a PR open in here for the talk. Not merged yet. So I tried to also install that PR, also didn't work. Well, great. So what do? I need to give a talk in a few days. I was panicking. It didn't work. I even tried to run the code, also didn't work. Well, I did something else. So this is the PyScript that was supposed to work, and it's just not there. Like you see, it was supposed to be there. It's not. The problem is that it doesn't render. So if you take, for example, the approach described on the official website, it just doesn't render properly. So it just shows you the code as a text, and that's it. If you use this one, it's pre-executed. So, well, I tried to find a different approach. You can also probably fork the code and then contribute yourself. This would be a solution, because PyScript is awesome. It would be nice also to have that little button to execute, like here. So this is from the talk. Like you click in here, and then it executes the code. You can also write in here, and also double execute the code. This is what I wanted to have. Then I found another solution, Jupyter Notebook. For Sphinx, it was super easy. You just write your file with Jupyter Notebook, and then it renders it into your documentation. So it creates the HTML out of it, which is very nice. It works out of the box. But there is also a problem with this. I mean, don't get me wrong, it looks nice. But this is it. So this is what you have. This is the code. And this is the result. It's pre-executed, and there is no way to make it live, unfortunately. Everything that is in the Jupyter Notebook, it has to be pre-executed. There are some exceptions. So, for example, if there is a long execution, like you need to build some graphs, the idea is to disable the execution and then put all the graphs as pictures into your results. This is the ideal documentation. So basically, either you contribute to the previous project that I showed, PyScript, which would be running nicely, or you just take what you have. So it's not interactive. I'm not sure if you really need interactive for documentation. So it really works. It does what it should do. You have the piece of code. You see the results. I don't think that you actually need to write the code interactively, because otherwise you can install packages and then just run it. So I would choose this approach, to be honest, because another approach took quite a while to figure out, and it didn't work in the end. And almost end. Yeah, so it's super simple. For Jupyter Notebook, you just install, you add configuration, and then you add the file, enjoy, boom, done. Took 5 minutes. Beautiful. But there is a problem, right? You can force people to write documentation with all the tools, but you cannot force people to read documentation. And this should be the culture that you need to build within the teams. And that's it. Thank you.
Please switch the microphone.
Okay.
This one.
Any questions? It doesn't work.
The other mic? Oh, we can just use this one. Oh, so Anastasia, how do you feel about documentation generated by AI? Any good tools to recommend?
Well, yes, and yes. So even doc streams, for example, you can put your code into ChatGPT and it would generate fantastic doc screens. It works pretty nicely. Awesome, fantastic, but security as well. If you work for a company, you cannot do that, because then you share your whole code with some tools, right? So only if you have some solution that you're paying for and they cover the security, then you can use it. For example, some, I don't know, supporting tools, but we didn't use it, to be honest. Like, there are so many problems in there. You explain what you need, and then it gives you a different result. So there are lots of hallucinations in there in the tools. But if you need some simple things, you can use the chat as well. Well, up to you. I would not recommend security-wise, but yeah.
How do you conciliate keeping documentation updated with frequent daily, typically refactoring?
That's a tricky question. Team culture, I would say. So if you don't have that team culture, it would take a while for people to get used to it. If you add the tool that checks how many lines of code are documented, what is the percentage, then it would mandate people to document the things. You can also check that as a checkbox for the code review, but you cannot force people to actually do that. So I would rather start with the team, talk with the team, decide on the team basis that this is the tool. If it's some open source, then yeah, just some checks on the CI.
You say documentations are like food recipes. Do you remember the documentation you enjoyed most in your experience, and why?
That's a very tricky question. Well, I enjoyed documentation about documentation from Daniele. This was the most enjoyable one because it has so much explanation in it and it's so clear to go through. But I think this was the best one I saw when I was preparing the talk. Yeah, there are lots of documentation. For example, AWS has a lot of documentation in there, and you can find anything that you're looking for. Sometimes for custom questions, you will not find any documentation which is good at. So it's also up to the taste, I would say.
So we still have room for questions. Do you have some awesome AI prompts for create documentation? Still about AI. What do you think about AI, which can pretty well document undocumented code? In this case, you don't need to spend time for documentation at all. or is it a good way to start?
Yeah, so for code reference, yes, you can use AI. For some very specific stuff, like explaining the why, I would say that you should do that rather than ask AI, because if you ask and then it's hallucinating, then it can make up a lot of things. For example, I wanted to write documentation on like future of the project. It was in the previous company I worked for, and we had a strategy. So I asked AI, what is the strategy that you suggest for the company? And the answer was so great. I was like, oh my God, this is so close to reality. But here and there were some weird things that I would not say that this could be possible. And I asked our C-level, like, is this something that we could consider even? And like, no, this is technically impossible at all. It was about hardware, so I'm not a very hardware person. I was mostly for the software, so I had to ask product people as well. And it was very close. Like, if you really look into the whole outcome, it's almost like you wrote it in the nice words. But it's still not. If you look into details, it would give you some weird answers, like literally it doesn't exist in the world and not possible. So if you want to use AI, if you want to use it as documentation tools, even for the calls, if you transcript everything, there is a nice summary in the end. And then summary, you need to check for sure. Like, you cannot save it as it is. And sometimes it might take even more time to produce the proper documentation out of the results than you will be writing yourself. So it depends also on the code size.
What are your suggestions about the approach for a fully undocumented big project?
Oh. Please do documentation. Well, you already need to start yesterday, I would say. I would say that you need a strategy for that. I'm also all into strategy. You would need a roadmap. That would be a nice thing to do. So if it's a huge project, you need to define how do you start. So whether you start with different modules, like you split into different modules, whether you hire a person dedicated to the documentation, this would be a boring job, I would say, or maybe fun job, it depends. And it might take a lot of time. So if you want to just touch the pieces that you are developing on and then add on the top, you can also include that into the CI, because CI would tell you like, okay, this PR needs documentation here and there. Like, as soon as you touch the file, it would just red light your PR that you need documentation here and there. But this is only for the code reference. For more advanced pieces of documentation, you need to define where you want to write everything. Here or there, like you need to choose the tool if you want to aggregate it all together or not. So yeah, you need a strategy for that, for sure.
Maybe the last question. Do you think that using more AI-generated code will change the documentation approach? Writing first, documentation first?
Well, probably not, I would say. It's like test-driven design. It doesn't work like that, to be honest. For documentation, you can write some papers, like this is the approach that we are going to use. And then it doesn't work like that. So like you even create a design document. This is the architecture that we are going to go. And then in a year, you would see it's way different that you said. For documentation of the code that is written by AI, it would just add doc strings out of the box. So that part is covered, but all the rest is not. So it's also up to you to make sure that AI tool has the request for you to write, like, oh, you need to write me this explanation of this way of, let's say, installation process. That could also work, but you also need to review that part.
That was the last question. Thank you, Anastasia. So we are done. welcome to Room Spaghetti. If you ever felt like writing software documentation is like doing taxes, maybe Maren Westerman here can help you. So let's welcome Maren. Thank you.
Yeah, thank you, everyone. I'm very positively surprised by how many people seem to be interested in writing software documentation. So amazing, thank you. So first of all, how did I come up with the idea of giving a talk about software documentation? I'm part of the Narwhals team and also Scikit-learn team. I'll give you some examples from these libraries because I know them best. And so on the Narwhals Discord server, there was a contributor, and the contributor said, could you create a documentation on how to write documentation? I'm always in awe with the docs you create. And I thought that was actually really sweet, and I thought maybe some other people might want to know as well. And if you don't know Narwhals, Narwhals is a lightweight compatibility layer between data frame libraries. And I came up with the title for my talk because often when people write code, they feel good about themselves. They're like, yes, I can do this. I'm really good. And then when they have to write documentation, it's like, ooh, how do I do this? Where do I even start? I don't know. And it's similar to earning money. So when people earn money, they feel good about themselves. They're like, yes, I'm earning money. But then when they do their taxes, it's like, ooh, why do I have to do this? And like, what is this all about? But yeah, so let's dive in. So first of all, we'll have a look at why writing software documentation is important. Then we'll have a look at what makes good software documentation. And then I'll go over the question of, can AI tools now do the job of documentation? So can we outsource this? And finally, I'll give you some fun examples that hopefully keep you motivated to write software documentation, or hopefully make you start writing software documentation. So here on the right-hand side, there's this, in quote, books. It says, excuses for not writing documentation. And at the top it says, where's the fun in just knowing what the code is supposed to do? And I think this already gives us a hint on why software documentation is important. And first of all, writing documentation is important for yourself. Because I think we've all been in this situation that we thought, I know what this code does, like it's very clear in my head. And then a couple of months later, you look at it again, it's like, ooh, what was my thought process here? I certainly have been there. And so you do this to document to yourself and also others what your code does and why it does what it does. And also with that, you can improve your technical writing skills. And so, yeah, by explaining it to your future self, you also explain it to others. And what's really important is that you explain the why behind the code, because from the lines of code, you can often see what it does, but not really why this function is actually really needed. And also you explain to others which kind of problem your project solves, or like which kind of problem a specific function, for example, maybe solves, and also how to use the code. And so in general, writing software documentation is about clarifying intentions behind the code. And it's also often a good starting point for new contributors if it's an open source library, for example. And it's a big open source library. It can be overwhelming to start contributing. So for example, Scikit-learn is huge. And when you start with writing documentation, you can find your way around the code base, and that really helps you with understanding the code base before you dive in deeper. And so now that we covered the why, let's have a look at the how-to. And these are the most important aspects that you need to keep in mind. So first of all, there are two types of audiences. First of all, users, people who want to use your code. They might not care so much about how it works internally. And then there are developers, so people who want to actually work on the code base. And so you need to keep these two kinds of people in mind. And then generally, you need to ask yourself the question, what does this code do? Who is this project for? Or what is this code for? And why is this project needed? Or why is this code really needed? So these are the basic questions that you need to keep in mind. And so here I'll give an example from the Narwhals library. This is an overview of the documentation page, or a screenshot of the documentation page. And you can see here at the bottom the question, who is this for? And there's just one sentence, so it's very clear and concise. It shows very clearly who is this project for. And then at the top left part here, where the arrow is, you can see the section why. So if you want to learn more about the project and why it's important and what kind of problems it solves, then you can click on the why tab. And so it's really clear, really concise, nice overview. So this is a really good example. And then what's also important is to write small reproducible examples. So here, this is a screenshot from the doc strings of the random forest regressor, so the random forest regressor class. And the doc strings of this class is actually 300 lines long, and this is just the example section of this doc string. And so it's important to have more in-depth examples in a separate place. So here, for example, in Scikit-learn, you have a gallery, and it shows all the kinds of examples that go a bit more in depth about how to use the random forest regressor. So that's a really good separation. And then what you also need to keep in mind is processes. So first of all, you need to have a contributing guideline, because it sets the standards for your project, and it sets the community values. And you also need to have clear installation instructions for people who want to run your code or use your library. And then you also need to think about a project license. It might not matter so much to you, but it might matter to other people who want to use your code. And generally, it's advised to only use one license, because otherwise this might get confusing. And then you also need to think about support, like how do you provide people with support, and you need to document that. So when your code is hosted on GitHub or GitLab, for example, there's generally an issue tracker where people can submit bugs. So you need to document that. And you also need to document how people can interact with the community, where can they ask questions, if they want to use your code or contribute to your code. And so you need to document, for example, mailing lists, Discord servers, or whatever kind of interaction you can provide for people who want to either use your code or work on your code base. And so here I show an example from the Scikit-learn library. Here there's a screenshot of the contributing guideline. And there's a gray box which says our community, our values, which is really good, because then you get an idea of what the general vibe is like, and you can see like, okay, is this project really welcoming and inclusive? And then also at the bottom where the red arrow is, you can see a link to an issue tracker. So this is also a really good example of documentation. And I'm also going to show you another example from the Narwhals library. So here you have the installation instructions, and you're given the option of either installing Narwhals using UV or Python's virtual environment. But regardless of what you use, the installation instructions are very clear, and they fit into this one screenshot. And generally, if you need more information, there are some links that you can click on. So here you just keep a very simple overview that people can follow. And that is also a really good example. And so now, the I think most interesting part maybe, the question, can AI tools write documentation? Can we just outsource writing documentation? And so what I did was I went into the Scikit-learn library and I deleted some documentation, and I said to GitHub Copilot, please write me some documentation. So first of all, I deleted the doc strings, the example doc strings, from the random forest regressor in Scikit-learn. It's the same example that I just showed before. And then I said to GitHub Copilot, okay, please write a small reproducible example of the random forest regressor, of how to use a random forest regressor. And so this is what came out. You can see this here on the right-hand side, and it looks pretty good. First of all, it's correct, and it has some extra details. It has some inline documentation, and also here we have a train test split, which we don't have in the original example. And that's actually really good because it makes it very clear to users that you should not use your whole data set for training machine learning models. And then also at the end, we are calculating an R2 score. which is really good. So by looking at it, the example on the right-hand side actually looks better. But as I said, the doc strings of the random forest regressor is already 300 lines long. Do you want it to be even longer? Does anyone even read the doc string if it's longer? Or do people just feel overwhelmed? So it's a bit of a question of what's best for users. So you really need to think about like, okay, do I really want to make the documentation longer, or is it maybe better to keep it really concise and have a more in-depth example somewhere else, as I said before? So I talked about this with the Scikit-learn maintainer, and he was saying, actually, I prefer the original example because we have loads of more in-depth examples somewhere else. And then what I did was that I deleted the N-estimators parameter documentation from the random forest regressor, and I said to GitHub Copilot, okay, please document this parameter for me. And this is what came out. So on the left-hand side, we can see n_estimators. It's an integer, default equals 100, and then a short description, the number of trees in the forest, and then some information about when this was changed. And you can see the exact same information on the right-hand side in the AI-generated param docs. But then there's a bit of a middle part. And in the middle part, it says, increasing the number of estimators can improve model performance, but also increases training time and memory usage. For small data sets, a lower value may suffice, while larger values are often beneficial for more complex data sets. I looked at it and I was like, this is kind of obvious, isn't it? But maybe it's not so obvious to people who just started with using Scikit-learn or just started using code to code. And so maybe it's actually really valuable information for more junior developers. And so I thought, I guess it's useful to have this kind of information, but maybe not in the doc strings of the estimators, because the doc strings are already so long. And then it also says here the default value is 100. This is redundant because at the top we can already see default equals 100. So this was this example. And then I thought, okay, maybe let's document a whole function. So here on the left-hand side, we have this function. Oh, sorry, not a function. It's a method, actually, which you can't see here. It's a method called getParams. And it has some doc strings, and I deleted the doc strings and said to GitHub Copilot, please document this method. And the output looks pretty similar. So the description is get parameters for this estimator, and the GitHub Copilot did exactly the same, generated exactly the same, and it also documented the parameter deep exactly the same as it was before. So in the Scikit-learn code base, there is another documentation of deep in another method, and GitHub Copilot probably just copy-pasted that and put it in here. And then when we look at the returns, we see that the method returns params, which is a dictionary, and then the description is parameter names mapped to their values. So this is identical to the original doc string. But then we have some extra information. And the extra information is, if deep equals true, we'll return parameters of nested estimators as well, with keys of the form component _parameter. And the extra information here is actually really valuable, I find, because it wasn't so clear. Like, yes, you can see that from looking at the function, but you really would have to look at it line by line, think about it. And so having this extra piece of information is actually quite valuable, and I think the AI-generated docstring is actually better in this case, like a little bit better. And so, in summary, going back to our question, can AI tools write documentation? I would say in clearly defined environments, yes. But there's a caveat. So they cannot go beyond training data and the context that they're operating in, and so they cannot be creative and they cannot create new ideas. They cannot be like, hey, you know what would be really cool? It would be really cool to have this kind of library that solves this kind of problem. This is not happening. And then AI tools also tend to produce a lot of output with sparse information density. So they often produce a lot of blah blah with not much content. And so you really need to double check, okay, is the content really clear and concise? Is it really really clearly communicated? Or does it maybe confuse people? And so you always need to double check. And you can, of course, improve this a bit with prompt engineering. You can say like, okay, hey, let's take this documentation. Let's say GitHub Copilot generated some documentation, and it's a bit blown up in the sense that it produces not very dense content. And then you can say like, hey, can you please summarize this content for me in 100 words or something like that. And so you can work with that, but still you cannot blindly trust the AI output. And so you always need to double check. And so in summary, AI tools, in my opinion, are good for assistance, but they're not really good for driving something, because you always need to double check whether the output is actually valuable. And so maybe some people have been asking themselves, will technical writers die out due to AI? And in my opinion, no. Because as I said, you always need to keep the target audience in mind, and you really need to understand your target audience well. And AI tools have generally a very limited understanding of the target audience. Of course, you can say like, okay, this is my target audience, and I have some, I don't know, maybe blog post here that describes the target audience, and read the blog post and write some documentation for the target audience. So like you can work with the prompt engineering, you can improve that, but still you need to tell the AI tool what exactly is my target audience. This is not something that the AI tool can do. And the AI tools also generally have a very limited capacity to describe why, or to, as I said, be creative. They can't really be creative. So that's still something that you need to do. And so you always also need to double check the work that they're doing. And so no, in general, technical writers are still needed, and AI tools will not replace them, but assist them in their work. And I wanted to show you this, the Zen of Python. I'm not sure if you know this. And so you can do in Python import this, and then it spits out this little poem, which starts with beautiful is better than ugly, explicit is better than implicit. You might have seen it. And this inspired some other developers to write their own Zen. So for example, in the narwhals library, there is the Zen of narwhals, which spits out this little poem and a really cute narwhal. And this inspired someone who was contributing to Scikit-learn to also write a Zen for Scikit-learn, and started an issue, and started with a little poem that he wrote, but no one submitted any suggestions. So he was saying like, maybe someone has any suggestions to improve it. But yeah, the issue is not very active. So if you have some suggestions for writing a Zen for Scikit-learn, yeah, suggestions are very welcome. So yeah, have some fun with that. And yeah, these are my references. So I took a lot of information from here, from Write the Docs. It's a really comprehensive library for documentation, and there's even a conference about documentation, just documentation, coming up this year in October in Berlin. And I can also recommend reading Read the Docs. So Read the Docs is a tool for building and hosting documentation, and it can partly automate writing documentation. Well, not writing documentation, but like building documentation. And it builds on Sphinx and Make Docs, which are tools for building documentation. And I can also really recommend to check them out. And there's also this tutorial by Melissa Weber-Mendonça for how to write documentation using Sphinx, and I can really recommend it. And this is the end of my talk. I hope that you learned something, and I hope that you had fun, and if not, at least I did. Thank you.
we have lots of different sources of documentation. What could be a good strategy or tool to aggregate them all?
Lots of different
sources of documentation. Yeah. The question is, what could be a good strategy or tool to aggregate these sources?
Yeah, that's a good question. Maybe someone can start a library that gives a good overview, or that maybe integrates a different kind of tools. That would be my answer.
Do you think it's faster writing the doc by yourself or improving the prompt to generate the docs with AI?
Yeah, that's a really good question. I recently had a discussion about this with a developer, and we were both saying that it depends. Sometimes it's easier if you just quickly do it yourself, especially if it's just a few lines, because learning to do prompt engineering is also a learning process, and so it takes a bit of learning to. It takes a bit of time to learn how to do it properly, and that is a learning process in itself, and you need to be aware of that. And sometimes it's easier to just quickly do it yourself, but in general, it's also good to learn how to improve your prompt engineering.
I'm not too creative in document generation, says Maxim. But documentation should be not creative, it should be documentation. Or am I missing something?
Yeah, I mean, there are different kinds of documentation. So often you document what? Like, for example, if you do parameter documentation, it's fairly straightforward. But then if you need to document who is this project for, or like why is this project needed, then that's really hard to automate. Like, you really need to think about it yourself. So there are different aspects of documentation. So especially when you're documenting, very clearly defined. When you do documentation in very clearly in very clearly defined environments, then it's easy to automate these things.
How would you handle changes in the source code that affect documentation in multiple locations? In other words, how do you make sure that documentation across the code base is always cross-consistent and up-to-date?
That is a really good question. The speaker before me actually gave a talk about continuous documentation and how to keep your documentation up to date. So I would actually just recommend to check out that presentation. It's by Anastasia Timoschuk, I hope I pronounced it correctly. And I cannot recall the title, but it was something about like continuous documentation and how to do continuous documentation.
Now a tangential question on docstrings. Do you think we still need to include parameters input section if type hints and good variable names are used?
Yeah, I mean, that's also a good question. I think it is always good to have a very quick summary of what a parameter is about, because it might not be so clear, actually. It might be very clear to you, but maybe not so clear to others, especially with people from different backgrounds. So I would always describe parameters with at least one line, like very briefly.
Do you think that the approach to documentation will change with more extensive use of AI-generated code, in particular for projects with specific business goals?
Yeah, I'm sure it will. So we are just at the start of using AI tools, really, and I think this is going to be a field in its own, and I think we're just at the start of the learning curve of how to actually use these tools, and these tools always get improved over time. So yeah, I think it will change a lot, and I think we just have to keep interacting with it and like keep learning, keep figuring out what can these tools do, what are they good for, what are their limitations. So yeah, I think it's going to change a lot, but in a good way, I would say.
We have still room for questions. Do you have any other question? I actually have one. I was here at Anastasia talk, and she was kind of pretty critic about the use of AI because of two reasons. Mainly, one was hallucination. So you save time by having your doc generated, but then you spend a lot of time checking it out because it pretty easily finds something that doesn't exist and put it there for everybody. On the other hand, it has some security issues in a lot of projects. So maybe what do you think about this?
I mean, these are definitely very valid concerns. Yeah, I think you always need to strike a balance between, like when it comes to efficiency, like really strike a balance between, okay, is it better if I just do it myself, or if I have this AI generated and I need to check every single bit of it. And yeah, when it comes to security problems, I'm not an expert in IT security, but I'm certainly sure that this is going to be a problem. And yeah, someone with more expertise in IT security, I think, can answer this question better.
Another question? Wait.
So I have a question. Generally, does every function needs to be documented? So for example, we have some kind of intermediate function that does a lot of things, but for code cleanliness, we split it into some steps that we do: fetch data, calculate this, and parse the result, for example. So it's obvious that the main function has to be documented well, but do the child functions, which probably are 1 or 2 liners, have to have the full set of doc strings that will clutter our code? Thank you.
I think it really depends. So for example, in the Scikit-learn library, there are many private functions or methods that are not really documented because only developers look at them and users generally don't interact with them. So generally, for example, in Scikit-learn, the public functions and methods, they're documented, whereas the others are not. Yeah, if functions or methods are really short, sure, then yeah, it's a matter of, is this really worth it? When you have a lot of users, when you are an open source project with a lot of users, it might be useful to still do the documentation for completeness. But yeah, sure. I mean, I've been in the position that I looked at something, I was like, okay, is this worth documenting at all? Sure, it's a bit of a matter of like personal preference, maybe.
The last question, maybe.
Thank you for the presentation, first of all. Do you use AI to generate documentation? Do you also use AI to check consistency of documentation?
Very good question. And no, I haven't. And this can be included in a future version of this talk. So thank you.
Yeah. So thank you. It was really interesting.
Hello. Oh, it's a very huge crowd. We didn't expect this. I'm Luca. I'm a backend developer, Python mainly, and
Yeah, hi, I'm Nina. Good old user experience and user interface designer, and this is my first ever PyCon, and I'm such a nervous wreck, and I will probably start to cry somewhere in between, so please excuse me. We work in Reversing Labs, which is a cybersecurity company founded some 16 years ago in Zagreb, Croatia, but we also have offices in Boston, USA, and we are really proud to be able to say that we built and are maintaining world's largest malware database. As you can imagine, 16 years of docs, and we work with large number of files, and reports generated by our static analysis engine produce a massive amount of that data. And beyond storing and retrieving that same amount of data efficiently, we also need to shape it and summarize it in a way that will allow our end users to intuitively understand the state of their software and which next steps they should take to protect it even better. But today we won't bother you too much about cybersecurity unless you want us to, then come find us at the bar or somewhere, yeah. We will talk about how good user experience and bad one even more can shape the design of your APIs, query optimizations and stuff like that. But first of all, what is user experience? I can see that all of you in the audience are young professionals, and probably it's safe to assume that you are familiar with the definition of user experience. And we all are familiar with the friction points between user experience and the front end, because it's almost natural for us to think in those terms. But on a more fundamental and deeper level, at its core, user experience is about understanding and maintaining complex system within a human context. So if I were placed in a cockpit of modern jet plane, my inability to perform well would neither bother me nor surprise me, because I'm not a pilot, and I do not expect for myself to be able to operate an aircraft. But as you noticed, in front of the Congress rooms are coffee machines, and I love to make myself a cup of hot macchiato. And if I'm unable to perform that operation within a few seconds or with a single button press, I would be fuming. I would be really, really frustrated, because I expect from everyday objects to be intuitive. I expect a good design to guide me, not to confuse me. Are any of you familiar with this book? Yeah, cool, yeah, okay, that's great to know. Don Norman is like guru of user experience design, and I really recommend this book because it's easy to read, it's fun to read, and it's still really relevant even though it was written in 1988. There is a bunch of other examples of everyday objects that become frustrating for people, for users. For example, we have popularly called Norman's door, with the handlebars that are clearly shaped to signalize that you need to pull them in order to open the door. And you stand in front of the door and you start pulling, but nothing happens. And then you see push sign, and you're a bit confused. It took few seconds of your life, you know, it's not a great experience. And I know I would probably hesitate in front of this panel with the elevator buttons, because I wouldn't be really sure which button to press to take me up and which button to take me down. So that's a bad experience in a nutshell. Good user face shouldn't make you think that hard about some action that should be really, really simple. And the principles in Don Norman's book can translate directly into the backend. Luca, I mean, I will tell you how in the UX and the everyday objects, but Luca will tell you how in the backend experience, BX, yeah. So first of all, you need to focus on your users and their needs. For example, a public transportation system places stops there where the people need them the most. And you have clear schedules, and the ticket machine is easy to use. And for UX UI example, you have food delivery app, which allows users to reorder favorites to filter by dietary needs, and so on. So user is first, and backend?
Well, backend is what powers everything. And why does user experience matter in the backend? Greatest example, if you ever wrote any software, is that you can complicate things if you don't understand your users. Your users will use your software in the way they think it should be used. Usually, it's not the way you thought it should be used or why you created that software. So there's going to be a lot of interesting behaviors. If you write APIs, you assume that your user will follow simple steps. Log in, view, click, and do some actions. If you do that, and it's not intuitive for a user, he will click multiple times on something that should be clicked only once, or shouldn't be clicked at all, and that will break things on the backend. Either you will run out of resources, you will have multiple connections on the database, you will have poor response time because you have 20 requests when you should have only one. So what you need to do is you need to understand your user so that the API is not driven by code, but by what you are trying to solve for your user. Because at the end, we are making money from those users, and we want them to enjoy using our product. If you do not, if you put yourself as a backend developer and you think only about clear, concise code, you are missing the point. You should be putting your user first and then try to solve their problem, not write beautiful code. I mean, you will write beautiful code, but let's be real, it needs to work first. And that's really, really important. So the other thing is, your users are not the only users of your code. You need to be aware that user experience also includes your colleagues who's going to maintain your code, or if you write library, other developers. So those are two separate users, but you need to make sure that you think about both of those. So if you write code that works for your user, but it's messy, not clean, without comments and documentation, your colleagues will hate you, and you will get fired. So don't do that. User experience also means developer experience. So please make sure that your next in line, who's going to maintain your code, is satisfied with your code. Also, that makes you happy because you will have friends at work, not enemies, so everything works, yes.
Do you want to start? Okay, for instance, signifiers, design elements should suggest their use. You have, I don't know, send button with a paper icon, a paper airplane icon, and standout color. It clearly suggests that you need to click it in order to send a message. And you all are sitting in chairs that are, you know, obviously for sitting. And if there are places for armrests, you know that you can put your arms to rest and sit a bit more comfortably. So that's about design that suggests use.
So back to the users. If you have very simple and clear design, that means that your product is easy to use. What that means on the back end is that you need to power that with enough data so that there's minimum interaction between user and what he wants to solve. Also, you don't want to send too much data, so it takes like 5 seconds to load a page. You need to be very, very aware of the amount of data you are sending, that it's enough for user interaction, but not too big, so it's slow. Why am I mentioning this? Because our product has huge amount of data, and we need to send huge amount of data to the user, and that's a problem. And that's really, you know, resource heavy, computation heavy, and it takes a long time to present it to the user. But our users expect it because they know that they want huge amount of data. So it's acceptable sometimes to have a bit slower response time if what you send has meaning. What does that do on the back end is when you have those kinds of functions, you need to be clear about the intention of your code. So back to your colleagues, you use clear endpoint names. So your front end and your mobile developers know exactly what is going on. If you are working with HTTP, use verbs. And please, get, put, patch, post, delete, everything, not get or post for everything. There are multiple verbs in HTTP, please use them, and use them accordingly. So if you want to update something, that's put. If you want to create, post, and stuff like that. So that's very simple and intuitive, because everybody in your team and everybody who uses your software as a developer will intuitively know what is going on. And it's easier to work across teams. Let's be real, nobody works alone. We always work with somebody else, and our users are other developers, other companies, and your end users. So everything needs to be clear and concise, and it should work without surprises. So if you use get but store something in the database, why? Why? So, please.
Okay, constraints and mappings. I inserted, actually I tried to insert the USB cable on the wrong part, but that's a good example because you can insert a USB plug only in one way, so you prevent errors. And UX UI example is a phone number input field prevents only accept digits, so it prevents users to enter wrong characters.
Exactly. What you want to do for your user is to stop them from overthinking. That's what constraints and mappings are there for. Your user, you should always assume that your user is a bit dumber than you are, and you should plan accordingly. You don't want your users to overthink when they use your product, because they will use it in a way that they think it should be used. Please don't do that. Make sure that it's clear and concise. If you want to input phone number, don't use those old-style telephones and make them choose numbers. Make it normal field that inputs numbers. Validate accordingly. Validation is not only on front end. You should validate minimally on 3 steps: on front end, on back end, and on database. If you don't validate your data in the database, you will have invalid data. That's a given. There's no other way of saying it. You need to validate in the database, because somebody will input something strange. That's a given. So if you are writing libraries, that means that each and every public function that your developer users will call needs to be clear, concise, and validate inputs. If you write something to database, you need to validate it on the database level and prepare data accordingly so you don't have surprises. Also, if you're doing REST or something like REST, you should always use clear, concise names and validation of user input and output. Why? You need to test your outputs, because your outputs are contract between you and other developers. And that must be unbreakable law. So if you have output, it needs to be valid and tested. So that's basically what you want. You want no surprises. So constraints, mappings, clear, concise names, that's the way to go.
We'll keep it short, so just feedback.
Feedback, well, feedback is how you know that you built something good. Your users will tell you. They'll tell you it's shit or it's good. Usually they are less vocal when it's good and more vocal when it doesn't work. And they are very, very, very loud when it doesn't work. Or it doesn't work the way they expected it to work. And you say, no, but it should be used like this. And they say, no. I will not use that product in that way. I want it to work like this. So you have conflict. So feedback, communication is the key. You need to work with your users, you need to understand them, and you need to make sure that there's clear communication between them. And of course, always assume there will be errors. That's a given. We are currently, 50 people here, all connected to a single Wi-Fi, and imagine one of us wants to watch a video. So that might mess up everybody else's experience of using the internet. So you should plan accordingly. You know that your user will have errors. You know that Wi-Fi will break. Your front end will stop working at some point because there's a lot of space between backend and front end. So please plan accordingly. Also, please don't use OK 200 and 200 OK, there's been an error. If you get 200 OK response, you expect everything went fine, not a tiny error message. Please try again. No, that's not good. That's surprising, and surprises are not good. So standardized and very, very clear error codes, naming, conventions, follow them. They are there for a reason. And
such a question. Yeah. So the design process contains 6 steps. In the first one, you need to understand your user. You need to learn about the problem, about the product actually first, the product's purpose, and you need to learn, what else you need to learn? How to solve a problem before trying to, you need to understand the problem before trying to solve it, yeah. And in the second step, you use previous findings to define your research, to define your wants, needs, goals, journey maps, quantitative and qualitative research, and stuff like that. And then you can ideate rough sketches, mock-ups, more brainstorming, more team communication, and so on. After that, you jump on 4th step, prototyping, and I mean Figma, high-fidelity prototypes, working prototypes, accessibility design, and so on. Then testing. Testing, I mean go back to your users and test it. Take their feedback. And only after those 5 steps are done, you can put your idea and your creation into effect. Without UX, it's a bit shorter process, and you always find yourself fixing errors. So the answer to the question, do you need a designer? Yeah, I think the answer is yes, because it's everyone's job, not just front-end team and design team. It's also, as Luca explained in detail, why is the backend team also need to understand the process of user experience. You need to ask yourself, firstly, are you solving the right problem, or you are making something just to look good?
And of course, why is UX very, very important on backend? Because you will interact with your users in a way that makes them happy. So if they are happy, that means that they will use your product, you will get paid, you will get promotion, you will go to PyCon Italy and have a good time. If they are not happy, if your product sucks, you'll get fired, you won't go to Bologna, and your life will be hell. So, but the most important part is communication. Like we said, if you don't understand your users, if you ignore half of your users and plan only for those who are paying for your product, and you ignore your colleagues, your developers, your mobile developers, and even the front-end guys, you will be less of a good developer and more of a pain. So user experience means all users, you, your colleagues, and the users of your application. So please, be gentle, be kind, and don't use, 200 OK error.
Oh, this is generated.
Yeah, we had to put AI image. It's the age of AI. Without AI, we are,
Thank you. We brought few these cool T-shirts. I think there's 6 of them, and Luca said that 6 best questions for him will get a T-shirt.
So we have 5 questions already. So the first one. Do you think domain-driven design can improve collaboration between their user experience world and the backend world?
From our experience, definitely.
Yes, because if you understand your domain, you will be less inclined to make mistakes while implementing. So domain, that's the primary focus of your problem solving. You need to understand what you are solving, what problem, and that's understanding the domain you are working in. If you don't understand it, you won't be fixing the correct problem, so you're working in vain. So yes, that's a great question. Here's a shirt.
Okay, maybe after. So, any suggestion how to deal with company directors that only think about backend performance and care about user experience only when the client complains?
Okay, let us curse in silence, because we need to be very gentle about words and stuff. So, okay, I'm calm now. Great question. Here's a shirt. You can come here. Yes. We will be gentle. You need to show by example. Let's put it like that. If you use yourself as an example how to collaborate and how to define that user experience and everything needs to be put first and do it by example, it will follow, because it will be easier for everybody to work and people will naturally start following you and there will be no friction. But you can also be vocal about it and say, we have poor performance because of bad UX. And that's why users are complaining. So please let me do my job and users will stop complaining. And if that doesn't work, change the company.
But also research, numbers, experience, few teammates that can back you up and so on.
And always mention money.
Yeah, that's a great advice.
So I want to learn more about this as a backend developer. Can you recommend a book or any other resources about this topic?
Okay. Except the design of everyday things, there is also Don't Make Me Think That Hard. It's another book. I forgot the author. You can Google it. I mean, those 2 books are the Bible of user experience, but there also are so many different tutorials and educational videos that you can watch, short videos even, and basically it's just about psychology. If you learn few those principles, you can adapt really easily to the backend.
Also, since this is Python conference, I want to mention 2 books, Serious Python, and I think I forgot the other one. But why am I mentioning those books? Because they have a clear way of showing you how to write clear and concise and good software. I think Python Tricks is the other one, yes. Also, read code. Reading other people's code will make you a better developer, because if you can't understand other people's code, you won't be able to write your own code good. Because let's be real, You rarely write something from scratch. You use libraries, you use frameworks, and you use other people's code. And you inherit projects. When you come into a new company, the project is already there. So you need to understand that code. That makes for easier interaction between developers. So that's also a good resource.
I'm sorry, I was sick a few days ago.
A lot of questions. Do you have any user experience advice for solo hobbyist developers in contrast to larger scale corporate teams? Advice for solo hobbyist developers.
I have advice. Open source couple of projects or contribute somewhere, because that will make interaction between you and other people almost a daily occurrence, and you will get feedback faster, and you can then actually expand your knowledge, and you will learn how to interact with others. Interaction is crucial, so pick one of the open source projects, start contributing, and then you can actually progress. Also go to conferences, of course.
Do you think that you should closely work in pairs, meaning UX and backend devs hand in hand from the beginning of the project until the end? Does it make it easier for the UX designer to be familiar with coding?
Yes. Like, I think it's... So these are all steps where everybody involved should be included, from the beginning to the end. You, as a developer, UX designer, your project manager who ordered that product, you need to interact with your users. You need to interact with quality assurance team. They need to understand what you are fixing, so they can tell you, please don't do this, it will crash. So quality assurance also should be included here. Don't forget about them. People usually think that step 5 testing is, QA. Right? No, QA should be at step 1. Also designers, also backend developers. It will be faster, trust me. If you start implementing on step 6, and this is the first time you ever saw your problem, it's going to be so slow and painful, because you have no idea what you are actually trying to fix and what problem are you solving. Because you get, I don't know, Jira ticket, implement API. That's not the way to work. And designers, they can code now with AI.
But I do know to click on the right mouse button and click inspect elements and find image source. Yeah, I'm
And we have other 6 questions here, but I think we are out of time. But Nina and Luca will be here, of course. Thank you.
Pino, can you take a photo from
Of course.
I want to know, maybe you have some practice to develop some not a good way, like not UX, DX developer experience in a
Hello, hello, hello.
Hello, hello. Is it okay? Closer? How about now? Is it better? Test, test. 1, 2, 3. Hello, hello. I can also speak louder.
Yeah, it's
okay.
Hello. Okay, so welcome, everyone. So we have Adrian with us. A round of applause for him, first of all. Great. And so he'll be talking on writing a Scikit-learn comparable estimator in the modern age. So let him take over.
Hello, everybody. So today we're going to talk about how to write your own Scikit-learn estimator. How many people in the room understand that sentence? Good. Cool. This has like this. I gave a version of this talk about like 2.5 years ago, and that motivated a lot of development that I drove inside Scikit-learn. And then I realized, well, my talk back then is not valid anymore. Things have improved, so I thought I can like give an updated version of the talk. But if you ask me how should you write a Scikit-learn estimator, one answer could be that, well, go to this page, which explains developing your own estimator. It's it's not that short. It is very extensive. It talks about what's an estimator, what does it mean to fit, what are the estimated attributes, a bunch of explanation, what's get params, set params, what's cloning, what are estimator types, what are tags, a whole bunch of stuff. What's check is fitted, the HTML rep, and all of that. But let's be honest, I don't think anybody's gonna go read that page to develop their estimator. So there is an alternative way of doing that, and that's what we're gonna explore in this talk. By the way, like I'm Adrien, I work at Probable these days. I'm one of the maintainers of Scikit-learn, and you have this talk and all the past versions on this GitHub repo. And since you know Scikit-learn, I'm not going to talk about that. But what are some of the main components inside Scikit-learn that most users would be exposed to when you write code that uses Scikit-learn? You have most of your estimators, like logistic regression, your random forest, your His-gradient boost, all of those. You have your scorers, your R2 score, and your root mean square, and like everything that's there. You have your CV splitters, k-fold, group k-fold, stratified, shuffle split, like all of those objects. And you have a whole bunch of meta-estimators, which include pipeline, grid search, and column transformer, to name a few. And what would a pipeline look like? If I were to write a very simple pipeline, it would look like this. I'm handling some text. I have like a count vectorizer, a TF-IDF transformer, and an SGD classifier. If I want to pass that pipeline to a grid search, how do I pass my parameter grid? Kind of with this syntax. I have the names, the name, dunder, and then the parameter name. Easy. But pipelines in more real use cases could be a lot more complex. This is from an example we have, which analyzes some text. It extracts the subject body from an email. It does some column transformation there. It has some custom transformers, like text stats transformer. And at the end, it's this like very long object. So what is this talk about? This talk is about how you would write these transformers that are your own instances of your own transformers, or in general estimators. Why would you write your own estimator? Well, first of all, we don't include every single algorithm out there. We actually have a ridiculously high bar for including algorithms, and a part of that is it's impossible for us maintain the library if we had every possible algorithm out there. To the point that like our documentation says you need to, like the paper talking about the algorithm needs to have at least like 200 to 300 citations. These days, even that might not be enough. So you might want to take an estimator, modify it. It might work for use case, or you're a researcher and you want to have something that other users can actually use. Also, we don't include anything that has a very small scope. And that is usually the case if you deal with some real data. You have something that works only for you or like in your company, but not for everybody, like that many people out there. And that means that those things are not going to be inside Scikit-learn. So you might create your own Lego pieces for your use case. Also, like for whatever reason, audit reasons or I don't know, logging, you might want to add steps to an estimator. You want to log the time that it took. You want to like log the data that was fed to an estimator, but you don't want to modify the behavior of the estimator otherwise. So you might want to write a meta-estimator to wrap around what's available in Scikit-learn. Also, please do ask questions at any stage. Otherwise, I tend to go too fast. So I need you to ask questions when you don't understand. And that's my fault if you're not understanding them. What's the basic API? Like the basic API that you're probably familiar with is like calling fit, calling predict. You have transform, and estimators also like the predictors have also a score function. And when you start developing your estimator, that's where you start with. But is that enough? And that's what we're going to find out. Here, we're going to start with, and we're going to do that together, so it might take a while. We're going to start with a custom classifier. And we know a little bit, so we know that a classifier should inherit from base estimator and classifier mixin. In fit, this is a dummy classifier. I'm not doing much. I just want to store what the classes passed to my classifier were. I don't really actually learn anything. And then in predict, I return only the first class. It's dummy, sure, why not? But let's see like how far we can get with this implementation. Something you can do in Scikit-learn is, also, is the text large enough for people in the back? Good. Sure. Better? Cool. We have this utility function check estimator that runs all our common tests on your estimator, and it gives you a lot of information about what's wrong and what you need to do. So let's run that on an instance of my classifier and see what happens. As basically expected, it raises a bunch of errors, and ideally these errors are going to guide you to fix your estimator. And let's go through a bunch of them and like fix what we have. The first one says estimator adds public attributes during fit method. Estimators are only allowed to add private attributes, either like started with underscore or fitted attributes that end with an underscore. What is this talking about? It's talking about this targets variable. So we need to make it private, and like by private, it's just a convention we have. It means like start this thing with 1 underscore, it makes it private. So I change that also here, 1 underscore. Let's run the test again. It gives me an assertion error. It says, well, estimator.fit, the output of this should be estimator. This is because our fit didn't return self. Okay. Fix that, run it again. Now, a bigger one. Estimator should raise a not fitted error when calling predict before fit. How can you do that? You can call check is fitted self. Okay, I know how to do that. Which means in predict, we should call this. Does this fix the issue? It raises a different error, but it is basically the same error. It's like, well, the instance is not fitted yet, but I just called check is fitted. The thing is, Check is fitted checks if your instance has at least one attribute ending with an underscore. Those are your fitted attributes. And I don't have that. I have one that starts with an underscore. Well, let's make it public. Why not? It's a fitted attribute. Or no, like an alternative is I don't want to make it public. I insist I want it to be private, but I can modify the way check is fitted work. I can do that by Scikit-learn is fitted. And I say return has attribute self underscore targets. This should give me a different error now, hopefully. Yeah, it does. Yay! So now it says fit does not set the n features in attribute. This is something that in newer versions of Scikit-learn, if you're using something like maybe it's 3 years old, you probably won't be getting these errors. But now estimators actually store what kind of data, what was the shape of the data, like shape in terms of how many features they had, like that was given to them during fit. How can I fix that? I need to call this validate data. Okay, I can do that. How do we do that? We say x, y, validate data, self, x, y. Now it says predict does not check for consistency between input number of features during fit via this attribute compared to when predict was called. And it also tells you basically your code should look kind of like this. In your predict, you need to have this line. I'm like, okay, I can do that. And also this reset tells this validate data that like I'm just checking things, don't set those attributes for my estimator now. Now it says I have the wrong inheritance order. I'm inheriting from the right classes, but classifier mixin should come before base estimator. There are reasons why these matter. Trust me, you don't want to know. So let's fix that and see what we get now. Oh, now it says my classifier object has no attribute classes. This is a part of the API. All classifiers should fit a classes underscore attribute, which stores the classes that was given to them during fit. Like, oh, okay, so in the end, this targets has to be called this, which also means I don't really need this now because now I do have something that ends with an underscore, but I can keep it. Why not? And then here I do that. Another assertion error. Now it says your accuracy score is not good enough. Well, I know it's a very dummy, stupid estimator. How do I fix that? You either fix your estimator, or you might know that sometimes it doesn't, or on small data or on the data that is available in test, it doesn't work that well. Now we get into tags, which talk to certain utilities in Scikit-learn and also the whole like testing mechanism in Scikit-learn. Let's customize that. Tags. How do we do that? We get our tags from my parent and change that. We say tags dot, I think, classifier tags. If I don't have a typo, poor score is true. What do I have now? Oh, yes. So that fixed that issue. It basically skips that test. When a classifier is passed continuous target, it should raise a value error. Okay. So like you need to do that test. The error message is not as good as the previous ones. It should ideally tell you how to fix it. And the fix is actually here. I can call check classification targets. Why? Good. What do I have now? What? Something went wrong. That's why you always have a solved version. Oh, that's true. It doesn't have an output. Well. Good. Now it passes. It passes and it gives you a list of tests that were passed, or if they were skipped, it also tells you if they were skipped. You can use this in like if you actually care about the tests. Okay, good. This is the first estimator that we wrote. Questions?
So in the fit method, why do we not get an error? Because now self.class is not private. Previously it raised an error because it was not private.
No. It raised an error because it was something that didn't start or end with an underscore. Like the convention is that fitted attributes that are a part of your public API end with an underscore. Yes.
Can you repeat the poor score part again?
Yes. The question is, what does this poor score does? Let's look at the error again. If I comment that, the error that we get, this is the error. We are training the instance that was passed to the test on some data, and we expect the accuracy score returned by predict method of the classifier to be higher than this very arbitrary value. And this arbitrary value is there because all scikit-learn estimators pass this. But I know for some reason my estimator doesn't pass that. And if you look at the line before that, is like it checks this precise tag. Tags does classifier tags poor score. So now I declare that this classifier will sometimes return a bad score. Anything else? Good. So like the three utility functions that we used was check is fitted, validate data, that if you're familiar with check array, which is kind of the old way that you were recommended to check your input data, now you call validate data, which calls check array. If you want to call validate data in order to store the number of features and all of that, but you don't want to call check array, there is this skip check array flag here, and everything else that you pass here will be passed to check array. So like you have all the options you have there, also here. And then check classification targets just like checks what the target is. Okay. An alternative way to run the tests, if you're using PyTest, is this parameterized with checks, which takes an instance of your estimator and also a callback that the callback would take the instance and return the tests that are expected to fail. Sometimes, so here one test failed and we fixed it or skipped it by declaring that like we might have a poor score, but sometimes for some reason there might be some other tests that you just like are not going to pass. You can return that list here and then they will be skipped. And then the way that the code would look like is this. Like you easily like create a PyTest, and then this is gonna take like the instance and the check, and it calls check on that instance. Then when you call PyTest, you will have like a really nice list of all the tests that are run on your estimator, and like all of them which failed with like all the like nice messages and all. But in a notebook, it's like a bit tricky to run PyTest, so like we stick with the check estimator for now. Okay, now moving on to a custom transformer. Here, what have we learned so far? We have the transformer mixin, then the base estimator, we call validate data, we return self. We are going to have a check is fitted that always returns true because this transformer doesn't really need to be fit. We are only adding one to the data. Some specific thing, like, again, why not? Some example. It looks all right. Let's run that. It says it does not raise an error when transform is called. Well, now we have two options. Do we want to call check is fitted in transform, or do we actually want this estimator to be a stateless estimator? We know how to do the former, let's do the latter. Again, that's through tags. We say my tags, I get it from my parent. And in this case, we say it doesn't require fit. And it works. Easy. Let's put it in a test. Let's put it in a pipeline. In a normal pipeline without the transformer that we just wrote, let's have a very simple one, a standard scalar and a logistic regression. And then something you might want to do if you have a pipeline and the last step of that pipeline is a predictor, you want to inspect what were the features that were fed into that last step. Imagine I want to look at the coefficients of my linear model, but I want to know what those coefficients kind of are attributed to. I can slice my pipeline, exclude the last step, and then call get feature names out on it. These would be the features that are fed to the last step. I can do that and I get the feature names. Now what happens if I add my own transformer here as a step? Do the same thing. Let's do that. It didn't work. Why? Because the myTransformer object does not provide a get feature names out method. The feature names and get feature names out are still not a part of the mandatory API for a transformer. Therefore, the test doesn't exist in check estimator. You can technically use it. But if you want to be able to use this feature in a pipeline, then you have to implement that function. In this particular case, I'm not really changing the columns, like I'm transforming them, but they're going to be the same column, like a standard scalar. And I can cheat and use this mixin, which adds that to the transformer. It's a one-to-one feature mixin. Still, everything passes, and now I nicely get the feature names, and the feature names are propagated through the pipeline. Any questions on this one? Cool. Also, the HTML rep works really nicely here. I didn't need to do anything. I mean, I inherited from base estimator. That's what you need to do. Now let's do something more complicated. I want to have a meta-estimator that this meta-estimator times the estimator that is in it, at least the fit time of that estimator. And it stores that in an attribute. Let's see what it takes to get this one Scikit-learn compatible. Let's run that, and then here I have three tests. I am wrapping a regressor, a classifier, a regressor, and a transformer, and I want to see like how it works. It's gonna fail for a while. The first thing is that the end feature is in. It doesn't exist. We know how to fix it if we are writing our own estimator, but do we want to do that, or do we want to delegate that to the subestimator? In a meta-estimator, you probably want to delegate it, which means here you can have a property that checks if the subestimator has it, then you return that, or we can try a hack. Today we are lazy, and we hack into Python the way that you usually shouldn't be doing. We have the instance and a name. What do we do? First, what is my estimator object here? I want to delegate to that. First thing is like here, as you notice, I have an estimator underscore that takes a clone of the input and then fits on that, which is what you should be doing. You should never be modifying your constructor arguments. So you first clone that estimator, and then you do something to it, and then you store it. Which means the estimator that I care about when this is called is either this one if it exists. If it doesn't, then it's the unfitted one. So it's this. Or if that one is none, self.estimator. Does this line make sense? Cool.
Can you repeat, like, or explain why do you should always be cloning? I guess that you guarantee some statelessness kind of thing.
Yes.
But then,
as in the one of the tests that we do have, like that, if you don't, it would fail, I guess, is that if you call fit twice on an estimator, regardless of the random state, but if you call fit twice on an estimator, you should get the same result on the same data. Which means you shouldn't be modifying, which also means you shouldn't be modifying your input arguments. Which is also the same thing that happens in grid search and cross-validate, like you always clone.
it's like because, for example, when you pass estimators to a pipeline or whatever, it always asks you to pass an instance, right?
Well, that's different because like pipeline doesn't necessarily know how to create the instance. Like you need to set the constructor arguments of the objects that you're passing to the pipeline. And also even check estimator, because even check estimator doesn't necessarily know how to create an instance of your object, because some of your constructor attributes might not have default values. Okay. And then here I return get attribute estimator name. And this get attribute, if name doesn't exist in estimator, it will raise an attribute error, which is what I want. But otherwise, I delegate it to my sub-estimator. Except here, it will go in a recursion if I don't add this. If name in time or estimator raise attribute error. Name is not there yet. Boo. The reason I do this is that like when is get called, it's called if Python doesn't find that attribute in your object, then it calls this one. And if it's calling me and time underscore or estimator underscore are not there, I know, well, fit is not called. I already know that, well, they don't exist. It also means this hack doesn't work if I'm looking into time underscore and estimator underscore of the estimator that I'm wrapping around. Accepting these, this should fix most of my issues now. Now, it says it didn't fail when I passed sparse data. Your tag says that you don't accept sparse. You should raise the right error. Well, that, again, comes from tags. How do I fix the tags? Again, I delegate tags to the sub-estimator. I say Scikit-learn tags, return, get tags, self. Okay, now again, I need this same thing. So let's put that in a function. And then I can simplify this part. And I just return my sub-estimator's tags. And now it works. It's a warning, but we ignore that. Now let's see how it works. Any questions for this one?
Yeah. Would it make sense to have some sort of like a mixing type of thing for the tags?
For inherit, like kind of delegating.
So that you don't have to kind of hook into these done school.
You could, but we usually, if the mixing is replacing a one-liner, we don't necessarily implement the mixin, because the user needs to either know how this works or know that that mixin exists. In terms of like information overhead that we like the user needs to know, it's kind of the same.
I was thinking more about the semantics of like going into an underscore method. It's like, okay, you're on your own kind of thing.
No, so yes, but like something that again is new in the past couple of versions is that if it starts with Dunder Scikit-learn, it is public recognized. The API is supposed to be stable. We actually support you. If you complain that something's not working and you're using a Dunder method, then we should fix it. It's different from like in the old days, this would be a method which was called underscore more tags, and then it was a bit convoluted and we removed that, and this is like the new way. But an alternative way to this get_attr is that you implement every single possible thing in the public API, predict, transform, predict proba, and features in, and you delegate that to the sub-estimator. It's going to be like a long list, and that's the kind of boilerplate. That, to me, yes, that should exist in a mixin. One of the reasons that I like giving these talks is that like when I give the talks, I'm like, oh, like it would have been nice to have like that kind of mixing. And then like if we do that, then it could also include the tag, because it's like in the same kind of boilerplate, and it's sure like it's a mixing that everybody who is like developing a kind of a simple meta-estimator that is only wrapping around a single estimator should kind of have. It makes sense for Scikit-learn to have it. Now, we are putting it in a pipeline and wrapping a whole pipeline in it. So it's a timed estimator. It has a pipeline in it. And the logistic regression is also in that timed estimator. Let's call fit. And then the last step of the pipeline, it has this time underscore. It says, oops, timed estimator object is not subscriptable, because this estimator is not a pipeline, it's actually a timed estimator. One way to fix that is to say .estimate, like that's your pipeline. Or if you really want your estimator like to behave like the object that it's including, that's what this should be doing. The get_attr, like what's the issue here? It says it's not subscriptable. What does this mean? It means that get_item is not implemented. So Python is looking for Dunder get_item and it's not finding it. The thing is, when Python looks for attributes or functions that start with Dunder, it doesn't call get_attr on them. It just says, well, they don't exist. So we have to special case that one, which means I say get_attr. It takes an index, return, again, get_estimator dot get. No, not get_attr. It's get_item. We pass the index. Except that this one ideally should only exist if my sub-estimator does have get_item. We have another utility, which is, we say available if it takes a self, returns self has attribute self.getEstimator get_item. Does this make sense? This available if is a decorator that is inside Scikit-learn. That's where you import it from, and it takes a function that returns a Boolean. And if it's true, then this thing exists. Alternatively, you could raise an attribute error inside your function if it's not supposed to exist. And yeah. And now, oh, self typo. Yeah. Yay! It worked. Are we clear on this one? It's a lot of mix of a little bit advanced Python, and like you need to understand scikit-learn. It's fun, at least for me. So let's put this in a grid search. Again, the simple pipeline without the timed estimator. How would I put it in a grid search? If I have a pipeline, I pass the name, dunder, parameter, and the name by default is lowercase of the class name. And then I can train on that. It's a grid search that has this as the base estimator, the best estimator, or I can directly get the best estimator, and it's like it has my transformer and everything. What happens if I put everything in a timed estimator? It works, it's gonna be okay, except that setting the parameter here, like what is going to be the text that I pass here, that's gonna be quite complex. One way to deal with that is that in my grid, when I'm passing my parameter grid to grid search, I don't have to pass parameters to the sub-objects. I can actually pass a whole list to the estimator, and this estimator is setting this estimator. What I do is I do a for loop on C, and I create a separate pipeline specifically for that C, and I pass a list of pipelines to my grid search CV. This works. This is always like a good trick if you have very complex situations where you don't want to explore the whole grid, you want to have like very complex ways of exploring subparts of the grid. You can pass a list of things that each of them is a generator, and then like it returns or it yields the objects that you want to search over. So I can do that. It works as expected. I have my best estimator, which has a timed estimator wrapping the whole pipeline, and the logistic regression is also wrapped around the timed estimator. But what if I want to pass that complex string and I don't want to have a list of pipelines? One way to find what the name of the parameter is always to call getParams on your object. It returns everything that you have. This is going to be a long list, but it includes everything. What was the thing that I cared about was this C. This is the name of the parameter in this setting for the C. I can simply copy that and put it here. Now, it's the same thing, like it looks like my previous code. I just changed this string, and it works. Any questions for this part? So what are some of the conventions that we talked about? Well, some of them we didn't talk about. Ideally, fit should only take, other than X and Y, it should only take things that are sample aligned. By that we mean like sample weight or groups. These are attributes that it's one-to-one, they apply to a sample. If you have things that are not sample aligned, or they're more of an estimator attribute that you could have set in your as a constructor argument, you should probably set them as a constructor argument. But there is no test failing on you if you don't do so. This is just a convention that we have. Init should not do anything other than setting public attribute that pretty much have the same name as the arguments that you pass to init. Everything else, every other validation should happen in fit. The reason for that is in grid search or in cross-validate, in a lot of cases, we clone the estimator and we call set params on it, and then we fit. Which means the validation that you would do in init is not run when we set the new value for the parameter in a grid search. So the validation should always be in fit. Attributes without underscore are the public constructor arguments. Attribute underscore are your fitted parameters. And if you want something private, you start it with like an underscore. And then n features in, feature names in, those are the things that store information about your data, that validate data these days, just store that for you. You don't have to deal with them manually. And we also dealt with a whole bunch of tags. In the documentation, you easily can see that. Like the tags are a few categories. One of them is input tags that talk about like what is my input. Do I accept sparse, which was something that we saw in one of the error messages. Does it accept categorical? All of those. And then I have target tags that talk about attributes of the target, the Y. You can set them here. And then you have the transformer tags that the only thing is like, does it preserve D-type or what are the D-types that it preserves? Which means if I pass it a float 32, the output of transform should also be float 32. Otherwise, by default, most of our transformers return a float 64, independent of the input type. Then you have classifier tags that the one that we used was poorer score. You have similar one like for regressor tags. Like the tags just collect all of them. I put a different section here because I wasn't sure if we're going to have enough time or I'm going to like be too fast. We're not going to talk about that. But there is a bunch of stuff happening. Some of it is already happened, like the metadata routing is like almost done. Some of it, like callbacks, is very much in progress. And I very much welcome you to read this document that I showed at the beginning and a few of the files in the repo. Like if you want, like really, like the documentation doesn't cover them. If you want to write your own estimators, it would be a good idea to have a look at these, like these few files. And thank you.
Okay, so we have got some questions for you. So I think, yeah, it's one. So how should I serialize and use a custom estimator in different runtime environment?
What?
So how should I serialize and use the custom estimator in different runtime environment?
Oh, serialize it. Well, that's a different talk. But you serialize, basically people serialize using pickle or joblib dump, which is also pickle. But if you care about security, what you should be using is scops.io, which is a different library that I worked on. And it has a module that it allows you to persist and load objects. And what it is basically, what is it here? It has this almost the same API as pickle, dump, dumps, load, loads. Except that it doesn't actually run arbitrary code unless you tell it to. That's the safe part. So these days, I would recommend the first thing people should use for persisting is scops.io. It's much slower than pickle. It's like speed is not its priority. If you care about that and you really trust your source and destination, then you can pickle.
Okay, so I don't think we have questions here, but anyone would like to ask anything from the crowd? Any questions? Okay, then a round of applause for Adrian.
Thank you.
wasn't saying anything serious anyway. Okay, now this works much better. A bit of the ASMR presentation. Okay. Okay, welcome again. My name is Luca. You see here another name on the blackboard, but not somebody else. That's because Gabriele isn't here, but I really wanted to thank him. He's a colleague of mine, a really keen data scientist. We work on this presentation together. It's a pity he can't be here, but still, big shout out to Gabriele, with whom preparing this work wouldn't have been possible and wouldn't have been so much fun. So, today we're talking about foundational models for time series forecasting. Who does a bit of forecasting here? Okay, okay, now it works, okay. Who tried it with statistical methods, such as ARIMA? Okay, a few amount of people. Let's go fancy stuff, autoregressive modeling with gradient boosted trees. Okay, works really well, doesn't it? Okay, yes. Who used transformers in forecasting? Oh, wow, okay, you gotta tell me, maybe you can swap places. So yeah, as we can see from the sample size, doesn't really happen very often to use those kind of models in your forecasting pipelines. And today we're going to talk about this and understand, for once, what are time series foundational models and which role do they play alongside forecasters based on transformers architectures, why they matter, and how we are building and evaluating them. And this, I do stress this out, building but also evaluating them, especially when we talk about data. And we end up with a bunch of words of caution when we want to try and apply them to the real world. So far, so good, right? Okay, let's dive in. Let's talk about transformers in forecasting. Why bother? Just one person used them. We do not ask them whether they worked or not. The point is, it sucks somehow. It takes a lot of resources. So much so that people such as Tim Janukovsky, who used to work at AWS and now works at Zalando, only find a meaningful use case when it came down to training transformers models, given the swaths of data they had over there. Forecasting teams such as Zalando or Amazon, they have data sets so big for which it's really makes a lot of sense to train those kind of models. They undercover pattern, they can handle data with seasonalities, but also missing patterns, sparsity, kind of different frequencies. So far, the only successful application that you can find of transformers, some of the most successful application of transformers, were constrained to specific domains for which there was a lot of data. You wouldn't want to use those on your airline passengers data sets, okay? But let's moving on to real use cases for data. Time series data sets are really varied in size. You can have monthly observation that come in because you're working to forecast, I don't know, sales of certain products. So you have weekly data more likely. Only when you go in some domains, you get data for which you have like hourly, minute density data, or even below those. And for those data sets, you might also have different SKUs or different units for which you want to build a forecast. So there's a lot of variety in these domains, and only in those domains for which you have enough data sets, it might make sense to train a transformer-based model. And there's what the next step goes, and the intuition that people like Tim had. Right now, I don't remember if you work on the Kronos dataset, but definitely the Kronos by Amazon was one model trained from the AWS user group. They realized that all it took to move from a regular transformer-based forecaster to a foundational model was to take up even more data. And if you think about it, it's really clever, and it kind of mimics what's been happening with large language models so far. People someday realize maybe we can try and switch from fine-tuning on specific domains or training a model on a specific domain to just train on anything we have. And the conclusion of the GPT-3 paper was that if you train the data on just predicting the next token, the model would just be inherently good at other type of tasks, such as classify this sentence or just extract entities from this one. And so what people did, like in Amazon and in other labs we can see, we're trying, yes, just scoop up all the data that we have in time series and train a huge model using all of those data sets. So no more just the domain data sets from, I don't know, retail forecasts or retail data sets and sales point from Zalando, but just any data set that we can get our hands on. And just let's hope that the model captures all the nuances that one can get from such models, so from such data, so domain, sparsity, pattern and seasonality, and skewness in a way, like, and all the sub-inherent patterns that you can get. And what they found out is that, or maybe they did this with the hopes of achieving one goal. zero-shot forecasters. So models for which you grab your domain data, you do not have to further pre-train your data on, like your model on those data, and you just generate a forecast with that. Which on principle, and bear with me for a second, assume that this works. This is not the end of forecasting, just to be clear, but this looks like a really promising and valuable tool one could use in their forecasting toolkit, right? Because then now you could just say, start working on your next data science project, and even if you have just, I don't know, 15 rows of data, or maybe like reliable data, you know, COVID happened for everybody, so if you're working with monthly data, here you go, you have like 50 data points or something. You can just start working with that. And see to produce a baseline alongside maybe your ARIMA model or your baseline model, you could just use that and see what comes out of it. So in a way, I'm not just saying that this should replace forecasting done the usual way, but this could make sense as a new tool for us data science practitioners to use. So this looks like really powerful because you do not have to, you can just ship something and see how that works and start evaluating it. While in the meantime, when the data collection happens, you start working on something more tuned to your domain. Or perhaps you could just take all of that data and just use it to fine-tuning. This is a point I will go on later, but just to keep in mind the end goal. It's not say, hey, these are the new ways of doing forecasting. There's just yet another tool. Look up how many possibilities it can open up for us. But this was the goal, right? Not if, like, we're just missing the huge, like, elephant in the room, right? Which is, do these models work? So this is what we're going to do for the second part, right? And this basically was what I was trying to say. The real point is we found, and there have been so many papers coming up in the literature for the past 2 years or so about data quality in large language model training. Everything boils down to data curation. You need more data, you can do even better if you have less data, but of higher quality. Can we kind of say, and it is no doubt that what made transformers-based models in the text domain, large language models, work was the availability of data. Okay, of course we had the architecture, of course we had the transformer, but like ceteris paribus, the data was that made all the difference, right? And can we say the same about time series foundational models? And in short, not really. This was Hugging Face this morning, and if you look for time series datasets in the other section, you get 32 datasets if you just filter for time series datasets. And if you look for datasets in another side of the page and really know why it's different, you get, oh, actually, that's the same screenshot. Oh, very clever. I didn't think of that. Very cool, but they were like in the hundreds. But if you just filter, oh, no, this was the good one. Okay, this was the first one. Okay, there we go. If I can cooperate with technology once in my life. Okay, let's just stand nice for the picture. Let's just pretend I'm saying something clever. There you go. So boom, boom, boom. Okay, let's just pretend I'm showing the right picture. But anyway, if you filter for the datasets for which there is more than 1 billion data points, you get like 2 of them. So in short, there aren't a lot of datasets, of open datasets for which we can train an open foundational model for time series yet. There is also this really famous Monash time series forecasting repository, which contains lots of data from finance, energy, and other domains with lots of seasonalities, but it has less than 1 billion observations. If you look at the time series pile, which was introduced with Moment, yet another model for time series forecasting, it has only 1.23 billion rows, but it contains Monash as a subset. The Lotsa dataset introduced with Moirai, which is a model, I don't remember the provider, but it's in, yes, thank you very much. It's more than 27 billion rows, so it's there, but keep in mind that large language models are trained with trillions, so like 3 orders of magnitude more data than that, which doesn't mean to be the same scale for time series models, but still just keep in mind that we're working on a data which is really immature yet in terms of data that we have here. I'm also missing a data set there that was released with a time MOE, which should be in the, I think, hundreds of billions of observations. So it's really promising. Something is catching up, but the field kind of feels in its infancy, which isn't bad, okay? Which doesn't mean it's not going in the right direction, but we have the benefit of knowing how this went with large language models. So we know that data will play a crucial role. We know what kind of data we need, what kind of principle the data needs to follow to train a decent large language model. So we can kind of do the same. And if we want to progress this field as much as we can, we need to focus on A, open datasets and broad domains, and B, open benchmarks. And up until like last week, we didn't have any entry on public datasets that we can use for benchmarking. And even the one that we have that comes from Datadog, which is called Boom, is for observability. So it's a really a subset of the domain, really like kind of niche subset of the domain that we can get. So there is still a lot to be done, and this clearly entails one thing. How do we evaluate those models if we lack the standard deference benchmark that we need to then contaminate our datasets from training from? Because if I train the dataset on, my data is trained on Monash, and then I just evaluate on Monash, of course it's going to perform better than models that aren't trained on that one. So as a community, I think that if the way that I understand it, we still need to find standards and procedures to do this, and we need to progress the field just setting aside datasets that work for doing like general evaluations and just not, I don't know, min-max those. This has a really practical implication. You should work on the datasets if you find the time to contribute to and advance the field. Secondly, if you're looking for adopting this solution in your business, you cannot look at the benchmarks they publish in papers. You need to do your own benchmarks. As we do with evals and LLMs, we will soon need to do this with time series foundational models if we see that they stick to the wall. Okay, so it's kind of green. But of course, when scarcity is there, we try to be creative. And what do we do then? Of course, we enter and we use synthetic data. Most of the papers I read, especially the ones that we're going to talk about, do heavily use synthetic data too, and they show in the papers that they have strong reason to assume that the synthetic data does play a role, a decent role. And synthetic data is generally generated in two ways. But everything boils down to take the existing data, do synthetic, like combination, linear combination of those, or add synthetic data from certain patterns, such as autoregressive patterns, create some fake data about it and just put it in the training data set. And in a way, this is just everything that boils down to it. But I found that like 10% or even 15, 20% of the synthetic data works on the performance of the model. I was trying to find the bottom to highlight something here. There we go, because I cannot just go on top of this one, otherwise you will stop seeing it. But in a way here we see, for example, from the Kronos paper that we're going to see shortly, the share of synthetic data, there you go, as it increases, the region aggregate relative score goes up. But the error goes up, of course, but you see that the most important part of the chart is here. When the data is increased from 0 up to, say, around 10%, you see a dramatic, like a significant increase in terms of performance of the model. So in a way, we can supplement the lack of training data that we have with synthetic data. For a moment, the model will learn apparently a much more diverse pattern of grammar of time series. So we can use it as much as we do with LLMs, where we can rephrase patterns of existing text, etc., etc. Comes to mind the Dolphin and also the Phi models from Microsoft. We can kind of do the same with time series foundational models and find an improvement. Stacchetto. There we go. Okay. Let's talk about models, because we've been ranting so far, like we've been setting the lay of the land, blah, 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 see, but do not forget about data. That part is really important, okay? I've been stressing it a lot because that's everything that matters in a way. Let's talk about models. We have a bunch of them, to be fair, and these two are fairly new, kinda. Time MOE was released like in the past month or so. Toto was trained by Datadog on observability and proprietary data, but was open source last week, forcing me to update the presentation. But in the end, we do have a bunch of them that have been trained in the past couple of years. So it's a field that's kind of been thriving. To be fair, I feel that like until like Toto and Time MOE, like in the past couple of months, there wasn't a lot going on in 2025, but I might be wrong on this one. All the papers are linked here. The slides will be public on speaker deck, so you can catch up and see all the resources that we used. I cannot talk about all of them, of course, but I focused on the two in bold, just because they were one of the first ones that they made a bit of a splash, and they have a really interesting architecture. You won't see here TimeGPT by Nixla, which is the OG model, like transformer model that scales to any domain, just because it's closed source, and I never had the chance to play with it. Not because they didn't let me, of course, but because I was lazy and didn't do it. And just open source those ones because we have the papers, we can see the implementation and try to see what data they use to train it on. And so let's talk about Kronos. And then we talk about times FM. There are truly different models trained on different principles and architectures, and I want to do a bit of a deep dive, not to say that these are the definitive architecture, but because they're really interesting to show in a way in the way that we can see how transformers are implemented and how we are reusing pieces of what we do with LLMs for those models as well, including other domains. So I find them really enticing and entertaining in terms of, like, as a data science practitioner, to go and read the papers, because they are really accessible in a really good way. You can read those, and even if you don't know anything about the domain, in a way, like, you don't have to be a time series expert or a transformer expert to understand those papers, because they really write it down really clearly. So it's a really enticing read. Highly recommended. I think we can make it. Like, how much time do I have? Like 30 minutes? 25? No, yes, of course, in total. Okay. Then we can speed this through. Kronos it follows an incredibly clever principle. The folks at AWS took the T5 transformer encoder-decoder that was used for Google to translation and say, hey, we already know the architecture. Let's just retrofit time series dataset to work with that model. So instead of patching the data or just finding a way to discretize the continuous domain of time series, they just did this. They binned the dataset. So for example, every observation that goes in the range from, say, 0 to 1 is assigned the token 0 and stuff like this with a bit of scaling. And they say, hey, let's just now feed the bins inside the model as you would with a time series, with a large language model. So every point in the domain is basically assigned to, I wouldn't call it a patch. A bin makes a lot of sense, like an interval for which a token is associated. And then we perform inference with those. So we do the forward step, of course. When we get out a new token, basically we just get a prediction in the interval. And this is really clever because it reuses the existing infrastructure. And by far the most clever thing that I found out of this paper was that, given that it's reusing the T5 architecture, you can use transformers for those models, like the Hugging Face transformers. You could just use the existing ecosystem and plug it in, and it should work in theory. You could train LoRa's with what we already have available to train those models. Really, that's a really clever point, a possibility that's been opened that we couldn't have before. And another really clever implication of these outputting bins is that since the large language model outputs a distribution, like a pseudo distribution in terms of logits, it's very easy for us to do inference and do probabilistic inference. So just say, okay, maybe just top P, all these parameters applies as well. But once we look at the distribution of the bins, there we go, we can also see something that looks like a probabilistic distribution out of the box for free. No need to apply any other method to know any other method. Really clever. The training data set contains a bunch of data from different domains. You see that you get energy transport, healthcare, retail. Most of the data has a seasonality, but also finance. And so they took a bunch of those data sets from the Monash repository. They also used a lot of synthetic data, like up to 10–15% of synthetic data, combining randomly real-world series, and also using this kernel synth, which fundamentally is just a way to say, like, we create some fundamental kernels, so like patterns of time series forecasting, and we combine those. You see here an instance of the method they use to generate those combinatorial patterns. Basically, you take the original real series, I'm talking about 0.1 here, and you assign a weight to those, and then you combine them randomly. So for example, you could combine series 1 and 2 and 3, for example, with different weights to obtain the series like DTS makes up on the right side. It's just saying that synthetic datasets for time series are just a combination of existing ones plus synthetic data patterns that have been generated that just multiplied together and added together to generate new ones. They found that the model performed quite well, except for one thing, like exponential trends, perhaps because they were underweighted in their generation distribution, but in general they found really positive results, which we're going to skim at the very end. Times FM goes on a whole different approach, which is equally as interesting. They go through let's just call it like a regular decoder transformer-based model with patches, so people from the vision domain should know about this quite a fair bit. They basically go through the regular transformer architecture. The only difference from what the people at Kronos did was that they, instead of just binning the data set, they just take a sliding window of the data set, for example, of patch length of 32, so like the 32 observation make up a patch, and they feed the patches into the model, and then the model can output patches of fixed length up until, say, 128 observations. So you get like the input size, it's binned in patches of 32, and you always get a prediction of 128, which means if you do maths correctly, 4 basically points prediction, 4-point long prediction. All of these here that you see, it's regular transformers, vanilla architecture. We can talk about it later, but I think we're kind of mostly familiar with that. They also do random masking of part of some patches to adapt to the context length, and in general, it's just autoregressive decoding. So you see like average pattern of autoregressive modeling as you would with Kronos. The really enticing thing about this paper is that they do publish a lot of ablation that we're going to see. Another thing is, and you will see that Google being Google, they do have a lot of data they can use to train those models. They use like Google Trends and Wikipedia page views. Of course, they sample those data sets. They take like the most frequent or mostly searched queries, like terms on Google Trends, and just use those patterns to train the model. Of course, this data isn't open because it's Google's in a good way. I mean, it's their proprietary data from Google Trends. Synthetic data was created using ARMA generators and seasonal patterns to build up another kernel bank, let's call it, like a foundation of fundamental time series pattern that the model learns. They do call it the grammar of time series. And then they sample like 80% of the data with 20% of synthetic data. And they range up in the, this wasn't updated, but it's not like 100 billion time points. In the paper, they say O of 100 billion. So they claim to have used something in the range of 100 billion of observation to train the model. They do a lot of, maybe not ablation, hyper-performance parameter runs. They found out that if you make the model bigger, it performs better. Good, which means that we can go on. I mean, imagine if it plateaued at 70 million parameters. We're like, okay, whatever, this adventure is done. They also try to generate longer patches of forecasts, and they found out that if it's longer, we have diminishing returns. Good, we can generate longer forecasts, which means lower inference. We can generate more data points at once. They also try to find like the optimal spot for patch length, so basically a way to summarize the information, and they found the sweet spot is around 32. So if you make it longer, the model loses in terms of performance in that we summarize more data into one single patch, losing a bit of detail. And then we start seeing the efficiency, of course, yet again, of synthetic data. They trained the model with or without synthetic data on all those data sets, and they found out that if they have it, performance is better. But here comes the problem. See, here, for example, you see that the times FM performance on ETTH, which is a dataset about energy and transit, times FM ranks better than other models, except it was trained on this model, on this data. So I'm not saying they're cheating, but here comes again, we are lacking the methods, the data sets to set aside for evaluation. So you need to be careful about this. Also, since these models do they use a transformer architecture and we're all into quantile regression and all the probabilistic intervals, we can see that both of these papers, and in general all the papers, do show forecasting for both WQL, which is a quantile regression error measurement, and then you also have mean absolute squared error. So you can see that this model, so far, as the authors claim, do have a decent level of performance and trade a bit of latency for that. Also, they should be trained, though, both in and out of domain. On the left side should be the in-domain prediction, on the right side, the out-of-domain prediction, and they claim that the model works fairly well. But the point is that to assess these abilities as zero-shot forecasters, we do need to be able to evaluate on data set that wasn't not seen during the training. One other thing that I'm really excited about, but I haven't explored none, I mean, I explored for myself, is that you can fine-tune those models on the domain to improve a bit and squeeze a bit more performance. But in the end, as I was saying, this is all really fascinating and enticing as in terms of a possibility, because you can see, we can start fine-tuning those models, we can start seeing them as zero-shot forecasters and use the data in a much more clever way, even if it comes from separate domains. Anybody could kind of fine-tune the model to their needs, because if my data in my domain contains a lot of seasonal patterns, maybe the model can learn from being furtherly trained on data from the same domain that has same, like, not even from the same domain, but has the same, say, frequencies or seasonal patterns. Yet again, though, as I've been saying way too many times during the talk, there is not a lot of publicly available data to train the model on, there aren't so many public benchmarks, so you need to be super sure about your internal evaluation metrics. If you do not have an evaluation system, you're not gonna get a lot of this one. And as a final note, we just experimented with those, just in non-production settings, and we set them aside. Not because they aren't worth it, because we didn't have the time to pursue the experiment, but in a vanilla form, you really need to focus on the domain. You need to be on the right domain. Maybe it works for you if you're doing like seasonal, I don't know, electricity domain. But then, of course, your hand-tuned gradient-boosted models might be just better in the end. But still, if you have the time to play with those, it's really fun, and it's really an enticing possibility where you can be innovating a lot, because the field is really burgeoning. So anybody could just be creative and take some of the lections that we have learned in the past couple of years and contribute meaningfully to this field. So without further ado, if you want to scan a QR code, get in touch with me or Gabriele. Otherwise, I will be around the venue up until actually Sunday morning. So I would love to get in touch with you if you have experience on any of these domain or any follow-up question or anything, any feedback about the presentation. It was a pleasure having you. Thank you very much.
Thank you, Luca. This is open, yes. We have time for some questions. So the first one is, how does model handle different scales in data, trend, and stagionality?
This is a good question. It really depends on how the model is trained. I didn't assess them wholly or extensively, but if you look at the papers, they try to showcase how they perform, especially if you go out to the oh, no, okay, whatever, it's gone. Especially if you look at the Kronos paper, they try to be really thorough in terms of how they evaluated performances in forecasts on trends and seasonality on data sampled from different domains. The bottom line is it really depends on the data that was seen during training. If the data has really weird patterns that are uncommon in training, of course you won't perform on those. But the beautiful part is that they can kind of catch those regardless of the frequency. So if they saw like some patterns that happens regardless of the frequency, they kind of learn the pattern and they can extrapolate even if the frequency is not the same. I hope I answered the question.
Thank you. So the second question is, what about multivariate?
I don't remember really well yet. I think that they can yield multiple forecasts at once. Some of those models, times FM for sure, can accept exogenous or other covariates. Some of those, especially when I was looking into the model a while ago, were mostly having support for just one series, like univariate forecasting. But the field is changing really fast, and it's just a matter of how you integrate those into your architecture. I think Moirai from Salesforce should accept more than one like target, not target, sorry, like the target and the exogenous covariates to train the model on. You should look by model. It's not the default option yet, but most of them are adding it now, so you can also use them with your personal data.
Okay, so the last one is, why are time series dataset often small? Couldn't we deploy Raspberry Pis with sensor collecting data at 1 second intervals to generate large volumes of data quickly? Time series data can be produced more rapidly than high quality text.
This is a really clever consideration. I have some friends here in the crowd also working with sensor data, and they say it's really hard to work with because you need to understand like where the sensor comes from, what's measured, etc. The short answer is I don't know. Or it depends. I think it's really clever, but we do not want to just have it run on the background. We also need to sample data from different domains. Finance data is the one we can get, but it's kind of pricey. We could want to get data from other domains such as healthcare, because maybe you can use those models to sample heart rate or something like that. So it's just not a matter of just say, hey, put a sensor in there and have it run. We need to be more aware in terms of different processes, and I kind of see that it makes sense as a starting point because in the end you can aggregate the data more. So if you have I don't know, a wind sensor going on the whole day, then you can aggregate it like a 15 quarterly minute level, hourly level, and increase the diversity. That would be expensive, but really interesting. Something that reminded me from a really good forecaster, I totally forgot the name, but he works at the London School of Economics at the Dyson engineering department or something like that. He was working a lot of forecasting and all the domain of sustainability, in also including building like greenhouses with a lot of fancy IoT and stuff like that. And I remember because we invited him over at a conference a while ago, and he was saying that somebody built like a really fancy building with lots and lots of sensors about like how the water was going, how the sun was hitting, and blah, 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 blah. And people weren't using the data in the end because it was expensive, because it was too much data. So we also need to think in those terms. Maybe the lesson we can learn or we can borrow from the time series, from the large language model domain is that we can just take better data and just work more on making the data sets that we train our time series model on more diverse, instead of just having like an oversample population of, I don't know, sensor data for weather, that maybe it's going to skew our predictions.
Okay, thank you, Luca.
Thank you.
And I just have a quick announcement. In 10 minutes, there will be the lightning talk session in Tortellini room if you want to join that session. And and at 5:20 in the keynote room, there is the Python quiz.
Ciao, eccoti! Ciao, come stai? Da quanto tempo, come va? Ah no, non sono più al Polimi, però PyMe, bene, siamo belli dinamici. Ti ridò il tuo McGuffin, bellissimo. Che cos'è? Da dove l'hai comprato? Amazon generico? Perfetto, mi piace molto di più. È stato molto faigo, ma certamente. PyMe tutto bene? Torino tutto a posto? In quelle zone? C'è chi, visto che c'è Torino, che sono belli incazzati loro. È un bel pezzo. Grazie mille. Andrea, Luca, piacere. Hai usato tu i Transformer, avevi detto, giusto? Eri tu la mano. Che fenomeno. Com'è andata?
Come sta andando?
Ah!
Vorrà ancora un anno. Ti ho cercato su LinkedIn.
Sì.
Se accetti il mio contatto, ho cercato anche il tuo collega.
Facciamo un catch-up, dai, bellissimo.
Uno slot mi racconta.
Cazzo, che bello, sì,
abbiamo
sì.
In questo momento benchmark di tutti quanti. Soprattutto
Siete in prima?
AWS e no.
No, che siete? Che zone siete?
Qui sono con un gruppo, un'azienda partner che si chiama DevPants.
Ok.
Che è sponsor.
Ok.
Però io lavoro qui al Tecnopolo a Bologna.
Ah, no, dai, facciamolo, anche solo per avere tipo una benchmark leaderboard su Hugging Face.
Il nostro uomo è di Nixla.
Bene, bello, dai, no, facciamo qualcosa. Dai, bellissimo. Andrea, aspetta che vado subito. Andrea De Marco.
Hai in pending la mia...
Molto bene, bellissimo, dai. Okay. Tu hai cose in impegno oppure posso mettertelo anche voi? Settimana prossima.
Scriviamoci.
Perfetto.
È complicato.
No, anch'io in effetti, poi sono via, sono a Londra, quindi sto dicendo. Allora, Rolando, Daniele, ok, catch-up, aspetta, perché non la vedo.
Te l'avevo chiesto già quando l'ho messo in agenda.
Scusami. The Big Bang Data.
Sì, quella è la mia.
Big Bang. Perfetto. Bellissimo. Grazie mille. A presto. Io devo correre allora, rivelare per il prossimo speaker. Bocca al lupo. Scusa, ma devo andare a fare tutto, se non avrei seguito. Ciao. Bocca al lupo.
Okay, so hello everybody. Welcome to this last session before the coffee break. Today we are here with Nicola Guglielmi, and with him we will make LLMs talk together in order to improve their performance. I want to just remind you that at 5:20 there will be the Python quiz at the keynote room. And that's it. So, Nicola, the stage is yours, and have a good talk.
Thank you. Thank you, everyone, for joining. I am Nicola Guglielmi. My work is last year, like a team manager. I manage a team of people that are very deep on cloud provider, on the three major cloud provider, and we do consultancy services. This is what I do for pay the bill, but I am technology, super curious about technology. I love to have hands-on code, and I am very deeply connected with Google technology. I am a Google developer expert and Google Cloud trainer. I am not a Google employee, just to be sure about that. In this talk I use some of Google's technology, but you can replicate it with almost any other provider of LLM and AI technology. If you missed it, I am not a Google employee. These views are my own. I just played with LLMs for a while, since the first version of ChatGPT, Gemini, and I saw in the last years a lot of improvement on this technology, but I see also that for a lot of tasks, the way they produce output are not at the expected quality level for be ready for a production. This talk was born from an idea from me and another developer friend, Alfonso Graziano, that was not able to join here for work commitments. And is grounded on the idea to use different LLMs together. We have a LLM promise that now seems that are ready to change a lot of industries, but when we use it, we see that sometimes the answers are not in target with our needs, or output miss some details that we may need to get the quality level that we expect for that specific job. LLMs sometimes are not defined in the request, so the output is not consistent and is not at the quality level that we expect, especially in zero shot. Why this is happening? Because sometimes a single LM is not cannot effectively critique its own output behind certain point. This is a limit of LLM itself. There is another problem, is problem of ambiguity interpretation. Maybe the prompt is misunderstood from the LLM itself, so the output is not what we expect. And one of the things that is something that I explored with my friends and my coworkers is the creativity versus accuracy threshold. We can use temperature to set this threshold, but we can use that just in one way with a single LLM. The core idea of this talk is about using an approach like the generative adversarial network in a multi-turn dialogue design, in which two LLMs engage in a conversational exchange, acting as a generator of content and a discriminator to interactively refine the responses and better understand what the user needs to as an output. Try to get a better focus on the user needs. This can be archived also in automated way or with human intervention inside the loop. This second option is very useful in the case you wish to improve control and have a better focus on the results. What is a GAN? GAN is a technology that has been was a hot trend for 4 or 5 years ago. From my point of view, was very interesting because it used two different deep neural network. One trained to recognize some specific kind of images, and another one that just starting from random noise, generate this image in a consistent way. I get in touch with this because I have a friend of mine that is a stylist for a fashion brand, and some years ago I saw a show generative adversarial network and also a bag generative adversarial network that started to design really nice shoes, really nice bags, in a way that is completely based on AI without human intervention. So in this design, what we use is like a GAN-expired approach. Two different LLM, one as a generator that create initial response, and a discriminator that make like an improve on the content that is generated, and also can validate it in a dialogue. If you want a more finer grained control, you can have a human checkpoint inside the loop, and you can use this just to provide feedbacks or confirm the correctness of the answer. This is a schematic of the pipeline. We start with an user prompt. We use an LLM generator that create our output, and we have another LLM that works as a discriminator that make a validation on this, and after we can also loop through another step inside our LLM generator, and after we can have a human checkpoint. What are the key benefits of this approach? The validator can push the accuracy and can be more aligned with the user intent. We can compress the ambiguity with interactive questioning and refinement. And generator can be used to explore higher temperature level that produce more creative, more in some way also more human output content generated, and the validator ensure that the creativity remains under grounded on what we need to have as an output. Sorry, I forgot. As a test, I have also a live demo. I don't know if we can do it. We try. We start with a simple user prompt, draft just a marketing email for a new eco-friendly water bottle. We can use, we can try this sample in several ways with like the web UI of LLM, or we can write code and we can push it through the API of the LLM. The nice thing is that with this approach, we can use multiple LLM from different provider, different vendor, inside the same pipeline. And this is one of the most interesting things, because we can ground this dialogue not only on like ChatGPT itself, but we can use ChatGPT as a generator, Gemini as a validator. We can try to spot which is the best for our specific needs and which perform better on our specific needs. We can try to play with temperature to get the right balance between creativity and to avoid hallucination. Okay, if we try this prompt with Gemini 2.5, we get one of the answer that we can get is this one. So we just ask for marketing email, and we have our output. We can take this output and put on Claude to have a refinement on this output, and we can align this to our needs. And after, we can also rate the answer. We can ask another LLM to rate this answer. This is very useful because when we start rating the output of an answer from an LLM with a numeric value, we can use this to take automatic decision on the quality of the output. This type of dialogue can be done also in different way. We can set a number of terms in our discussion, or we can have like a threshold limit, and the LLM continues to improve the output until the that threshold is reached. Just a quick overview on temperature. What is temperature? Temperature lets you to direct the kind of output that is generated. With a low temperature, we have more predictable, but often very common patterns for our output, good for something like summarization for very precise and puntual tasks. Mid is something that lets you to have a good balance between creativity and you can have it on topic, and is general purpose usage. High is less coherent, more creative, good for brainstorming, to try to exploit new idea from common prompt. And with this kind of approach, what we do is just using high level of temperature for generation and lower level temperature for the discrimination. In this way, we are sure that we ground on our needs without losing the possibility to have new idea, new content in our output. The temperature scale is from 0 to 1 from most of the LLM. In Gemini is from 0 to 2, but is the same, just the scale is different. We just a quick recap of the difference between the two approach. In some benchmark I can show you, we have with the manual human review, we saw in in several companies in which I work for content generation, we saw very nice improvement, and also with another approach that is multi-LLM, we have very great benefits in the quality of the output that we get. We can have human in the loop. In this case, we orchestrate the two or multiple LLM using humans that act as a judge on the quality of output. This is very good for tasks that need some kind of criteria that are just human-based. Very good to define the path of the LLM dialogue to keep it on track, and setting direction of our goal. We can have different kind of intervention inside this loop, with just a confirmation, with correction, clarification, and writing the output of validator over the time. So what we do is just starting with the generator and validator with two different temperatures. In the next step, just add the human in the loop if we need to have a better control. But we can improve also this design using agents. With agents, we can create scoped LLM for a specific task, and this let us to define a more complex system to generate content and review that content based on different scope for different reviewer. Like if you write an agreement for your company for a job that you have to do, this agreement usually go through the sales department, the lawyer department, the CEO for approval. Each one of these work on a specific matter inside that agreement, and you can do that in automatic way. There is a very nice library from Google that has been released a few months ago that is ADK, Agent Development Toolkit, that let you to build this network of agents that can break down complex tasks in something that can be managed. You can interact also with the external API to integrate more data while you are producing your content, and you can arrange these agents to work together to reach your goal. In this design, we have just different agent for different step of our process of generation and validation. But this is just an incipit of inception of idea, because we are exploring the design space with symmetric and asymmetric rules. So we can have LLMs that can generate in different way or in a collaborative way content, like a team that make a debate. And you can increase the number of LLMs in a way that you can have benefits from specific grounded agent that make like quality control or fairness control of your content generated, and let you to have very high level of content that you generated. So single LLM are very powerful. Usually you can use it for a lot of tasks, but if you need higher level of content for for your use, for a specific usage that you need. You can make these LLM talk together to generate and validate the output. This is useful to balance creativity and to incorporate in some way the human intervention inside the generating process. Okay, I left just some link if you wish to go deep on this. There are also some code. I'll publish it ASAP because I need a review on it, and I miss my co-speaker. Okay. If you have any question, I am here to answer. Okay,
just some of them. So
if we cannot answer any question, you can just drop me a message on LinkedIn, and I'll answer anyone.
Okay, so the first question is, do you think this approach can only be used for batch use cases, or you think there's a reasonable way to have overall system response latency under control for online use cases like chatbots?
Absolutely, yes. You can use, for instance, an agentic design. You can use several agents. In that case, I may suggest smaller models for low latency answer, but you can use also for that.
Okay, so the second one is LLM as judges have a known positive bias, especially in point-wise evaluation. Do you do something to mitigate that? The LLM as judges has a known positive bias.
Yeah.
Do you do? Okay.
Yeah, you can, as I showed before, you can instruct a specific LLM to ground their intervention on a specific area of the generated text. For instance, you generate content. You want that content is fair. Okay, you can instruct an LLM as an agent just for a fairness check on a specific boundary that you can have. After that, you need to be sure that the content itself is legal. Okay, so you can have another agent that can do just that kind of check, like a company. If, as I said before, as an example, if you write an agreement, you need different people that work on it. You have a technical team that build the proposal. You have a sales team that build the commercial part. You have the legal office that build the legal part, etc. In the same way, you can build a network of agents that can refine the content you build. But the nice thing of this process is that you can have this agent with a lower temperature, so you can be quite sure that that agent act in a predictable way. But you can have the generator with the higher temperature, so you can generate more creative content, more like human content. Okay, this is the nice thing is that you can mix these two level of temperature, and other things is that you can use multiple LM, not just from one provider, from one vendor. You can mix together, and mixing them together, you can get the best from each one in each single specific area of expertise.
Okay, thanks. Sorry, I just have to move here. Okay. So I will join two questions because are similar. Okay. So, in your opinion, is this approach better than proper prompt engineering? Also considering that the cost of this pipeline is probably higher than just using one LLM with a good prompt. And the second one is, does this answer refinement technique worth the cost of each LLM API call?
Okay, it depends on the use that you have for the output of this pipeline. I work with a company that makes something like content generation, so the output has an higher cost, higher price, respect a single interaction, for instance, for a bot, for a chatbot. So it makes sense in this specific use case. But for instance, if you write something, any corporate document, makes sense to have a very scoped network of very scoped agent on specific area of that document to improve the quality. Yeah, but you have to pay for several calls. But also keep in mind that each single cloud, each single provider of LLMs now has a lot of give a lot of tokens for free. For instance, there is I don't know if you someone use Grok, not Grok from X. There is another Grok that is a quantized model as the open source model, and you can use for a lot of tokens each month.
Okay, so supposing the validator needs access to the same specialized prompt used by the generator, what about the efficiency cost trade-off of using an LLM validator? So no, this is quite the same.
It should not have access to the prompt that uses the generator. You have to have a division just to have the model. And this is also the reasons I don't suggest to use the same model for generator and for validator, because you are trying also to explore different settings for temperature that give you creativity, give you more human-like text. I also experimented with images, and this is working for some kind of problems. But no, I don't suggest to give access to the initial prompt to the validator.
Okay, so how will you compare it to temperature control?
Just temperature control?
Yeah,
you don't have the control on the, you cannot get the same overall quality level that you can have with higher temperature during generation and lower temperature during check. You get lower quality. We did a lot of benchmark on this with human rating, and the human, the people that make the evaluation rated higher the content generated by this pipeline.
Okay, so the last one that actually are two related. Was GAN still used in agentic solution? And is there a demo that shows a workflow involving GANs and agents or any papers? Could you provide some references if available?
For this kind of approach, yes, I can provide. Yes, there are. I saw a paper on Medium, I suppose, about design like this one, but I'm not sure. If you drop me a message on LinkedIn, I'll follow up.
Okay, so thank you, Nicola.
Thank you, everyone.
And so we finished, and you can enjoy your coffee break and the Python quiz session later.